Hey everyone, this video is an introduction to Sass and responsive design. It's part of my course, Responsive Design for Beginners, which you can find more info about linked in the description. In this video, I'll walk you through what Sass is, setting up your files, and building a demo website with Sass that'll show you the principles of responsive design. Sound good? Let's get into it. So what is Sass? Sass stands for Syntactically Awesome Style Sheets and is a CSS preprocessor. That's a lot of jargon to just say we're running styles in a way that's easier for developers to code, but that code has to be converted to CSS in order to make sense to the browser, hence a preprocessor. There are two syntaxes that you can use when writing Sass. The original syntax, just called Sass, is similar to CSS but doesn't use curly brackets or semicolons, instead simply relying on indentation and new lines to differentiate your style rules. Files using a syntax have the extension .sass. On the other hand, SCSS is more popular and what we'll be using in this course. It is much more similar to pure CSS, and an added benefit is that you can copy and paste pure CSS into your SCSS files with no problem. These files have the extension .scss. Now, in order to write your styles, you'll need a way to compile Sass to CSS. In this video, I'll show you how to do that with the VS Code Live Sass and Live Server extensions. In my full course, I do also go through a more advanced method using gulp, so if you hear me mention gulp in this video, that's why. Alright, so this is the beginner route for compiling your Sass files to CSS. I'm going to be walking you through how to install the Live Sass compiler and Live Server VS Code extensions, and then how to configure and get them up and running. So first, make sure you have your VS Code open and you have your project folder open in it. Now, to install the extensions, if you don't have them ready, in the far left activity bar, click on the bottom extensions menu icon, and then search for Live Sass Compiler. Now, you might see more than one Live Sass Compiler extension, and this is because the original extension was authored by Ritwik Day. Unfortunately, he has not updated it or maintained it in 3 years. So what happened was someone named Glenn Marks decided to fork the extension and is currently maintaining his own version, which is using the new version of Sass, which is what we need for this course. So when you select the extension to install, just make sure you have the one that is authored by Glenn Marks. So to install it, click the install button. And then once it is installed, we do need to do some configuration. So if we close all these things, let's open our Solution Explorer, and we want to open the command palette. So press Ctrl-Shift-P or Command-Shift-P if you're on a Mac, and then type in Open Settings. And what you want to do is select the Preferences Open Settings Adjacent option. And once you do that, it's going to open up your settings JSON file. And this is where all your VS Code settings are stored in JSON format. So we're going to add some lines to the file in order to customize the Live Sass extension that we just installed. So to do that, scroll all the way down to the end, and then before the closing curly brackets, we're going to add a new line. So for the current last line that you have, make sure it ends in a comma, and then start a new line. So on this new line, every property needs to start with a quotation mark if it's a string. So type in a quote and then type in Live Sass. And you should see in the autocomplete menu, it'll pop up a bunch of different Live Sass compile options. So we want to select the Live Sass compile settings formats option. So if you click that, VS Code is going to generate a whole bunch of different options for that. And what we want to do is when we compile our Sass files, we have the Sass files in the app SCSS folder, but we want to generate the final CSS file in a different folder called dist. So we can set that configuration in this save path option. So instead of null, we're going to set it to a string, meaning we need to enclose it in quotes. So add some quotes and then type in // that is, dist, and then save that. Now, I don't know exactly what the files not in a workspace warning is, but I think it might be a bug currently with the extension, at least at the time that we're recording this video, but the compiler itself should still work fine. So what these settings do is that they're going to make sure that we compile the Sass files to the final CSS file in a dist folder, which it will create. If you don't have this and you leave it at null, which was the original value, it's just going to compile your final CSS file in the same location where your Sass file is, which is fine too, but I personally just like keeping my compiled files in the dist folder. Now, if you want to minify your final CSS file, meaning compress it to save space, you can change the format option. So instead of expanded, what you can do is, and here's a trick when you're updating your settings JSON file, delete everything in the value and just type in quotes, and it should detect what your options are. So you can say compressed if you want minified, or expanded if you want to not minify your CSS file. So whatever option you choose, you can just save that. Now, once you're done changing all your settings, save the JSON file, and then that should be pretty much it for customizing the live Sass compiler. Now, you're also going to want to install the live server extension, also authored by Ritwick Day, and in this case, even though the extension hasn't been updated, it still works fine, so we're going to use that here. So if you type in live server, what this extension does is it will just launch a local server and open your project files in a browser window like a real website. And it's kind of cool because it has this live reload feature, so it should reload the site anytime you make a code change and save it. So if you don't have this installed, click the install button to install it on your computer. Now, once you have both extensions installed, you might need to reload your VS Code window in order for the extensions to load correctly. And you can tell that by, let's say you open your index.html file. If you look in this bottom bar here, you should see a Watch Sass button on one side and then a Go Live button on the other side. And if you don't see those, then I would maybe try to reload your VS Code. And you can either do that manually by closing the window and reopening it, or you can use your command palette. So Control-Shift-P, and then type in reload and select the developer reload window option. And then when you've opened your project folder, you should be able to see the Watch Sass and Go Live buttons down at the bottom. All right, so to compile your Sass files, you can go ahead and click the Watch Sass button. So if you click that button, you'll see a terminal window pop up if it hasn't already, and it should say something like watching. So it's watching your Sass files. And you may have noticed that it generated a dist folder with your style.css file. So let's compare. We have our style.scss file here with just a few test styles. And then in the dist folder, open up your style.css file and you should see the final CSS. Now, because I set my options to minify, it tries to save space and put everything on one line as much as possible. And what you can do is you can toggle the word wrapping in VS Code with Alt-Z, the Alt-Z hotkey, and then you'll be able to see everything without having to scroll horizontally. Now, if you want to test this, let's make a little change to our style.scss file, and let's maybe change the background color to a slightly different color. Let's make it a little bit lighter. Now, if we save the file, let's keep a watch on the terminal down at the bottom there. So we're going to save style.scss. And it said change detected in the style.scss file, and it's generated our style.css file and the map file. And what this map file does is, let me word wrap that. It will tell you the original location in the Sass files of what the CSS style is. And this is pretty useful when you open the website in the browser. I'll show you that in a little bit. When you open the website in the browser and you look in your inspector, it will actually tell you specifically with a line number where the rule came from in your Sass files. So it makes it just a little bit faster when you're trying to troubleshoot your styles and debug and figure out where a certain rule is coming from. Okay, so we've checked that the compiler is working, which it is, and also that it detected a new change when we made a new change and pressed save. All right, so now let's test out the live server extension, and we want it to load a local website loading these website files. So if you go down to the bottom again, click the Go Live button, to run live server. And it should pop up the website in a browser window, and it should load, 127001, port 5500. The 127001 IP address is your local IP address. So that indicates that it's a website that's run not on the internet, but just on your computer. Okay, so we have that working. And let's try changing the background color again, just to make sure that everything is doing what we want. So we'll go back to the darker gray color. We're going to save. And we can see that the Sass has been recompiled. And let's check our website. And now the background color is that darker gray color. So it seems like everything's working, which is pretty awesome. Now, if you want to stop running the local server, what you can do is, instead of the Go Live button, it's now replaced by port 5500. And clicking this will close and stop the server. So then now the server is offline. And I'm just going to click Don't Show This again. And you can also stop watching your Sass files by clicking that, and then it'll turn back to watch Sass and go live. So now nothing is being watched. So let's just click those back on again. And it's running again. So let's go into the local website and let's look at the code in the inspector. So what you can do is right click, and then there should be an option. I'm using Firefox, but there should be similar options whether you're using Chrome or Safari, either developer tools or inspect element, something like that. So click inspect. And what we're going to do is look at our code. So we can see if we make a little bit of room here, and then I'm just going to close this bottom JavaScript stuff. So we can see the actual HTML code that is getting loaded onto the page. So if we click the body, then in the bottom panel, we can see the styles for the body element, and these should match what we have in our styles. Now, if you remember when we were talking about the CSS map file, if you look here on the far right of the selector, it says style.scss and 1. The 1 is the line number, and then it's telling you that the style rules here for the body element are coming from the style.scss file. So that's exactly what we have here in our code editor. And this is the final CSS file. So there's only one line, so that's why the style is coming from line 1. But this comes in really handy when you have, a whole bunch of styles for a website. Now, the first thing I wanted to talk about with Sass is Sass partials. So Sass partials are one of my favorite parts of working with Sass, because instead of having to, look through one giant long CSS file, you can actually split up your styles into multiple files and even keep them more organized with subfolders. So this allows you to keep different parts of the website separated into different files, and it makes it kind of easier to locate styles when you are debugging your website. Another part is having your styles separated into these different files will allow multiple developers to work on the code base at the same time, with a lower chance of more than one developer working on the same file at the same time, which decreases the chances of having a code conflict in your version control. So in our project, the first partial that we're going to be creating is for some boilerplate styles. Now, these are some general styles that I use on pretty much every website that I work on. These boilerplate styles are what I sort of consider global styles, so I'm going to be creating a global subfolder because we're going to be adding to these global styles. So in the app SCSS folder, I'm going to create a new folder, and I'm going to call this globals. And then in the globals folder, I'm going to create a file. This is going to be our first Sass partial, and the file name is underscore boilerplate.scss. Now, in our boilerplate Sass file, I'm going to start creating some of these styles. So the first one is the HTML selector. And I'm going to say box sizing, border box. And I'm going to say font size 100%. So that font size 100% is kind of for accessibility purpose, because this will make sure that the font size on your website is going to match 100% of the default font size set in your browser. And this is something that you can change in basically any browser settings. So this will default to 16 pixels. And the box sizing border box thing, it ensures that if you add padding or borders to an element on your website, it means that it'll be included in the final width or height of the element. So this means, let's say I have a box that I've set to be 300 pixels wide, and then I add 20 pixels of padding on all sides. The final width is still going to be 300. It's not going to add the 20 pixels of padding on each side, making the final width 340. So this is generally more desirable when you're setting width and height of things, because it can get kind of confusing if you add padding to any width that you've set already. So after this, I'm going to add a wildcard selector with the asterisk, and that will select every element. And then I'm also going to say before and after pseudo elements. And for this, I want to say box sizing and inherit. And this will inherit the box sizing value of box sizing border box from your HTML element. I basically do it this way because I saw CSS Tricks do this on their website. And for some reason, they just say box sizing inherit. I'm assuming because HTML is your root element, so you want everything to inherit from that. Then let's go back into our style.scss file, and we're going to cut and paste that body selector that we had down here. And I'm just going to make the terminal smaller so it doesn't take up so much space. So here we have the font family, the background color, and then the color, which is text color. And I'm also going to add margin of 0 and padding of 0. So these are what we call resets. These resets are helpful because browsers are going to usually have some default styles, and they will add it to any website that they load unless they get overwritten by the styles in the website code itself. And these values can vary from browser to browser, so it's often helpful to add reset rules like these to your website code. Okay, so that's it for the boilerplate styles for now. And I'm going to create another partial in globals, and I'm going to call it underscore typography.scss. And in this file, I'm going to add some styles that are related to text elements. So H1, that's the headline 1 tag, H2, and H3. And this is a compound selector, so we have those multiple selectors separated by a comma. And for these, I'm going to say font weight 700, which is bold. Then we're going to set a line height of 1.1, and this will make sure the line height of each line of text is going to be just a little bit taller than the font size itself. So the 1.1 kind of means 110%. And then we're going to add another reset rule here, and that'll be margin top of 0. And again, that's because browsers are going to, by default, add a margin top and margin bottom to a lot of these elements. And I don't like having a margin top. I like just having margin on one side. So I usually work with having a margin just on the bottom. And then we'll do the same thing for the paragraph or p tag. I'm going to say margin top of 0. And you don't need to have a unit if it's 0 because, 0 pixels is the same thing as 0 rems. So you just need to say 0. Then after that, we're going to do anchor tag. These are anchor or link tags. So A, and then A visited, and A active. So this will affect all links. And what I'm doing is removing the default underline that browsers add to links. Okay, so now we have our two global Sass partials and then our main style.scss file. So you might be wondering how do we load the styles from these partials since they're in their own files? They're not, in style.scss file. So one way we can do this involves creating another partial in our global subfolder. And I'm going to call this underscore index.scss. So I generally like to keep one index file in each Sass subfolder. This kind of helps with the organization. So in this index.scss file, I'm going to load the other two Sass partials that we created. And we're using a Sass at rule called forward. So forward, and I want to load boilerplate.scss. So we can say, in quotes, boilerplate, end it with a semicolon, and do the same thing for typography. So what we're doing here is we're using that Sass at rule to load the styles from boilerplate.scss and typography.scss. And you might notice that even though the file names themselves start with that underscore and end in .scss, all we have to do is write the words boilerplate and typography in our index Sass file. You could write the whole file name out if you wanted to, but Sass will just detect if you have the same name without the underscore and the file extension. So it's a little less to type, which is kind of nice. So what forward does is pretty much just take all these style rules in these parcels and forward them on to get loaded. So the index.scss file is taking those styles from the globals folder, and then they will get forwarded into our main Sass file. So in our main style.scss file, we're going to do something similar. We'll say forward. Let me get in the first line there. Forward the globals styles. And in this case, all we have to do is type the name of the folder, globals, and this will automatically look for this underscore index.scss file. Okay, so we have our Sass files saved. Let's go and check our compiler. And you can see that it did detect the different changes that we've made. And if we go all the way down to the bottom, it says watching. It doesn't have any error messages. And if you hit save again, so I'm pressing Control S to save, you can see that it'll automatically run the compiler again. And I had that little success message. So that's a good indicator to know that everything is okay with your Sass compiling. And I'll also check on the terminal, and it looks like there's no errors here either. So that's good. So now that there's no errors in our Sass compiling, the last thing we want to do is check the actual website and make sure we don't have any errors and that our styles are loading. So we have our developer inspector open. And if you don't have this open on your computer, you can open it by right-clicking and saying inspect. I'm using Firefox, but other browsers should have a very similar functionality. It might say inspect element or developer inspector. You can also hit F12 to open this panel up, or Control-Shift-I, and I believe that would be Command-Shift-I if you're on a Mac. So let's check. We have our body tag here, and it does look like it's loading the styles from our Sass files, which is great. Then HTML, we have those boilerplate styles that we added, and it's also telling you where this came from. Boilerplate.scss, line 1. And then boilerplate.scss, line 12. And we have this display here telling you the actual Sass file and the line number because of the source maps that we generated along with the final CSS file. So right now everything's getting compiled into the dist folder. And if we open that, we can see we have our style.css file here. This is the final minified CSS file. So, it tries to fit everything on one line as much as possible. If I press Alt-Z and VS Code, we'll wrap the line so you can read all of them. And the other file here is style.css map. And this map file, it does what you might expect with the word map. It will map the final CSS rules to the original Sass files where they came from. And having a source maps file helps a lot when you're debugging because it tells you exactly where this style rule came from. Okay, now if we looks like there's some errors here. So let's click on that and see where they're coming from. Okay, so it looks like this is kind of the same error. The resource from yada yada script.js was blocked due to a MIME type text HTML mismatch. Now, I am including this error on purpose in here because this is a very common error. I actually get quite a few comments from people saying that they're running into this error message. So I figured I would include it in the course so that if you haven't run into this error yet, you probably will at some point, and now you'll know why. So what's happening is the browser is saying it can't load our script.js file for some reason. So let's click on this link and see what happens. See what happens when it tries to load the file. So this is saying, let me zoom in here, cannot get app script.js. This is saying for some reason it can't find this file. So what we need to do now is debug our script.js file and figure out why it's not loading. So let's go back into our VS Code and then open our, let's see, index.html file. So we've loaded our script.js file up in the head, and it's loaded in the script tag app/script.js. And then let's try to find this in our file. So our script.js file is in the app.js script.js file. And you might notice that this path has the JS subfolder. So it should be app.js script.js, but here in our index.html file, it says app script.js. So there's a mismatch here. So what we need to do is correct the path in our index.html file to match the actual path in our project files. And this is why the error happened. So there we go, we'll save. Let's check our website again. And it looks like we only have one error now, which is good. And the error is, let's see. Oh, the favicon. So the favicon is the little icon that you see in your browser tab when you load a website. And we don't have one yet here, and that's why this error is happening. That's not a huge error. We're going to fix this later on, so you don't need to worry about this if you're seeing it yourself. Okay, next up, let's talk about variables. Now, you may have heard variables being used when talking about programming languages like JavaScript. And without getting super technical, variables are ways that you can store bits of information and then give them a label with a name. And usually this name is sort of descriptive, so it lets you understand what kind of information is being stored in that variable. And they are called variables because the information associated with a name can change. So you can set it to be one thing and then change it to be something else later on. So Sass and now CSS both have variables. In CSS, the variables are officially called CSS custom properties, but people often refer to them simply as CSS variables. So I might use both terms in this course. So why do we want to use variables in our styles? Well, if you use variables to refer to things like color values, font styles, spacing, and so on, it makes it easier if we need to change those styles later on down the line. You define the variable and its value in one place, and then you can have multiple style rules that need to use that value refer to the variable instead of the actual value like, 20 pixels or the color blue. Also, it's just kind of easier to remember, let's say you're setting colors like dark gray when you're writing code instead of the hex or HSL color value. So let me show you what I mean in our project. So in VS Code, in the boilerplate Sass file, we have our body selector, and it has a background color set to this sort of dark gray color, and it has a color property set to basically white. These are both set in HSL, which is a format of colors that you can use in your CSS styles. Now imagine that we wanted to use this background color and text colors somewhere else in our styles on our website. So if we didn't use variables, we would have to manually copy and paste each of these color values to whatever style rules needed to use them. Then if we had to change those colors at some point, because web design can always be changed, we would have to then do a find and replace to replace every single instance of this color with the new color. And this can be very time consuming. I have done this myself at my job, and it took quite a bit of time. And that's time that could have been saved if you'd simply set the color using a variable and then use the variable everywhere else in your styles. So let's move these color values into some CSS custom properties. In the globals folder, let's create a new file, and we're going to call this _ since it's a partial, colors.scss. And of course, since we are creating a new partial in globals, we need to update the index Sass file to say forward colors. So it's just a good idea to get into the habit of every single time you create a new partial to make sure you update your index Sass file. Now, in our colors Sass file, we're going to create our CSS custom properties. So generally when you're creating CSS custom properties, you want to set them on the root selector. And this is :root, and then that's the selector. So it is similar to other CSS style rules using those curly brackets. Some people also might set them on the HTML or the body selector, and that's totally fine too. Just know that the root selector is going to override any values of the same variable name that might be set on HTML and body. So the root sort of takes priority in things like that. But you can also set the CSS variable in any selector. So if you wanted to save, say, the spacing of a card element in a variable, and you only want to use that variable for cards, you could set the variable up in the card selector itself. So how you use them is up to you. I have noticed a lot of people setting the variables in the root, so they're kind of like global variables at that point, but it also might make sense for organizational purposes if you wanted to have some local variables set just in the selectors where they're going to be used. Now, these colors are more of a global thing that I might want to reuse in a bunch of different places, so I'm going to be setting them in the root. So let's create our first variable name. So I want to name this one background color. When you're creating CSS custom properties, the names have to begin with a double hyphen or a dash. So this would be called hyphen hyphen background, another hyphen color. Then add a colon to set it, and then we're going to copy that background color from here and set it there. So that's our first CSS custom property. Now let's create another one for the text color. So again, hyphen hyphen, and I'm going to say text dash color. And then I'm going to go and copy that value from boilerplate and paste it in there. So now we have our CSS custom properties set up. Now let's load them in our body styles. So back in the boilerplate Sass file, we can load the background color variable by typing in var for variable and then the name. So it's again hyphen hyphen background dash color. And we can do the same thing for the color property here. So var hyphen hyphen text dash color. So let's save that. Okay, so looks like everything compiled correctly. Let's check our website and make sure they're actually loading. Okay, so it looks like the colors are loading in our website, and in the inspector, we have the body selector selected, and we can see now that the background color and the color properties are loading our CSS custom properties. So they say background color and text color, and then if you scroll down, we can see that it's inheriting the values from that root selector that we created, and you can see the actual hex codes for the colors that we created. And these are displayed in hex colors because the browser is ultimately going to translate any HSL colors into hex on the website. Now, Sass also has variables, and they are similar to, in some ways, but different from CSS custom properties. With Sass variables, the way it works is that your compiler is going to convert any Sass variables into their final CSS value in the actual style.css file. CSS custom properties are newer, and since they're native to CSS, you can get the benefit of using variables without having to use Sass if you don't want to. In addition, one big benefit of CSS custom properties that Sass variables don't have is that you can actually use JavaScript to change the value of a CSS custom property after the website is loaded, which is pretty cool. And people use this for things like dark light mode on a website because you can use JavaScript to update the values of the color, on the fly. So in general, it does seem like people are replacing Sass variables with CSS variables, but I'm still going to show you how Sass variables work because if you're working as a developer in the field, there's a pretty good chance that you might have to work on some legacy code at some point. Not every company will stay up to date with the very cutting edge of things, so a lot of places are just going to keep using, out-of-date tools and technologies that still honestly work fine. So we stored our colors using CSS custom properties. I'm going to use Sass variables to store the font information. And just to note again, we could be using CSS custom properties to store this stuff, but I'm using Sass variables just so you have a chance to see how Sass variables work and kind of how they differ from CSS custom properties. So to get our font info, let's go to Google Fonts. And the font I'm looking for is called Open Sans. So we'll click that. And then we have the family selected, and we need to select the weights that we want. And I want regular, which is 400. So I'm going to click select this style. And then I also want bold. So that is, if we scroll down, bold is 700. So we'll select that style as well. Now we have our fonts and our font weight selected. We need to then get some code to copy into our index.html file. So you can see here it says use on the web. To embed a font, copy the code into the head of your HTML. So they have some helpful instructions here. So we're going to copy this code here, go back to our VS Code, and in our index.html, I think I closed that. There we go, index.html. I'm going to paste the code in our head tag, which is up here at the top. And I'm going to paste it before our own CSS file just to make sure that we don't cause any issues when loading the Google Fonts. So paste that. And then we can see that it has a bunch of link tags to Google Fonts, and then it's loading a CSS file from googleapis.com. So I do want to note one thing because we're using Google Fonts. At the time of this recording, Google Fonts has actually been found by a court in Germany to violate the GDPR regulations because they can track the IP address of users of the website when they load your website, if you're using Google Fonts this way that we have here. So I'm not sure how things are going to resolve, but I just wanted to mention it since it is kind of going on and GDPR might be a concern for you. So if it is, what you can do is a workaround where you actually download the actual font file from Google Fonts, which you can do, and then host the font files locally on your own website server instead of loading them from Google servers like we're doing here. It is a little bit of extra work, and I think explaining that whole thing is a bit out of the scope of this course, but I did want to mention it just so that you know what's going on right now with Google Fonts, since they're pretty commonly used on the internet right now. Okay, so for our fonts, since we're using them with Sass variables, we want to be able to load that font value into other Sass files. So we need to use something called Sass modules to make the Sass variables accessible from any of our other Sass files. This might sound a little bit confusing, but let me show you what I mean. So instead of adding another Sass partial in our globals folder, what I'm going to do is create a new subfolder in our SCSS folder, and I'm going to call that util. And of course, since we created a new subfolder, we have to add the index.scss file. So underscore index.scss. And in the util folder, I will create another file, another partial, and call it underscore fonts.scss. And then we're going to forward the fonts file in our util index.scss file. So in fonts.scss, we're going to create a Sass variable to store that font family from Google Fonts. So for Sass variables, you start all their names with a $sign. That kind of signifies to Sass that it's a Sass variable. And we're going to call this just font. And we're going to set that with a colon, and then we want to set this to the actual name of the font family from Google Fonts. So let's go back and get that. So if we keep scrolling down here, it says CSS rules to specify the families, open sans, comma, sans serif. So we're going to take that, maybe without the semicolon, and then go back into VS Code and set it to open sans, sans serif. Now we want to load that font. So what we want to do is copy that name and then go back into our boilerplate Sass file. And instead of Arial, Helvetica, sans serif, we're going to load the Sass variable. So paste that. When we save, we have an error. So let's see what that error is saying. So it's saying error undefined variable, and we can see probably the same thing in gulp. Yeah. Same error message, undefined variable. So what the live Sass compiler and gulp are telling us is saying that this $sign font is an undefined variable, meaning it doesn't know what the variable is, which makes sense because we put the font in this whole separate Sass file in the util folder. So we need to load that Sass partial from utils as a Sass module in our boilerplate Sass file. And this is sort of similar to what you might have seen in JavaScript or other programming languages where you load or use other code files so that you can use functions and other things from them in other files. So what we want to do is load all the util styles as a module. Right now we just have the fonts.scss file there, but we will be adding more as we continue on. So the way to load another Sass partial as a module is to go to the target Sass file, meaning the boilerplate Sass file in our case, and then at the top of the file, we're going to add a Sass at rule called use. So at use. Then we need to add the file path from boilerplate.scss to the util folder. So we're starting in the globals file right now. So we're starting in the globals folder, and we need to get up out of that and go one level up to the SCSS folder and then navigate to the util folder. So to go one level up in file pathing, we're going to use a double dot. This means one level up. So it goes up out of the globals folder into the SCSS folder, and then from there we want to navigate to util. So util, and that should be our file path because it will automatically look for an index.scss file in the util folder. So all we need is that folder name. So now we can save. However, it looks like we're still getting this undefined error. And this is because we have to use a namespace whenever we're loading a Sass module. So by default, Sass is going to give it a namespace that matches the name. So right now, the namespace is going to be by default util. So when we're loading the Sass variable, we have to preface it with the namespace name. So util dot font. So now when we say we have that success message, and it looks like there's no further errors. So this namespace thing is to kind of keep our different variables and other Sass features separate. Before Sass modules existed, you had to be very careful to make sure that you weren't using the same variable name more than once because things would get overwritten and it would be very confusing and difficult to debug. So having namespaces now means that we can have another font variable in a different Sass partial from util, and it would be okay to use both of them because of the namespace here. Because they would be loading with different namespaces, they wouldn't conflict. And you can also set the Sass modules to be any namespace. So let's say we don't want to have to type out the whole word util. We can say use util as, and I could just say the letter U if I wanted to. And this can be any string that you want. So then we're loading util as U. So we can just say u.font. And again, looks like everything's okay. We don't have any errors way down at the bottom. And lastly, if you don't want to use namespaces at all, you can say wildcard. And then you wouldn't have to use any namespace when you're loading the variable at all. But then you are going to open yourself up to that problem of the possible name conflicts. So I personally think it's safer to use namespaces in some form. So let's just load it back as U. U.font. Okay. So now that our Sass files seem to have been compiled without any errors, let's go and check the website. So our body tag is selected, and when we look in the rules, it says font family Open Sans, which is exactly what we want. You can also see here the difference between CSS custom properties and Sass variables. The font family just says Open Sans. It doesn't say the var type of thing here. And this is basically what the final CSS file is. And this is because the Sass compiler has converted that font variable into the actual value, which is Open Sans sans serif. The background color and the color properties are using CSS custom properties, which continue to exist in the browser itself, again, since they're native CSS. To illustrate some other Sass concepts and also get into how responsive design works, we're going to build a demo website. This is going to be a 2-column layout with a main section and a sidebar. So let's go into our index.html and make some changes to the code here. Now I'm going to wrap the h1 and the paragraph tag that we have here in a main tag. So with Emmet shortcut, we just need to type the word main, hit enter, and then we have the main tags generated for us. So I'll move this up into the main tag. If I hold down Alt and press up arrow on the keyboard, and then save, and Prettier will automatically put the tags where they need to be. Then our main content is going to be here in this main tag, and I'm going to add an aside tag, which is going to be the sidebar. Then in the aside, I'll add an h2 tag. Again, just typing in h2 and pressing enter. I'll say more info. And then under this, I'm going to add a paragraph tag. Using emit, I'm going to say paragraph, and in that paragraph, which we'll denote with the angle bracket, I'll say lorem 30, and this will add 30 words of lorem ipsum text, which is placeholder text. And let me wrap this by using the Alt-Z shortcut. And save. So the main tag and the aside tags, these are both what we call semantic HTML tags. And this is where the tags themselves have a meaning separate from any CSS rules that you might apply to it. So the H1 tag is another example of a semantic HTML element because the H stands for headline, and then the paragraph or P tag is yet another one. The main tag means that this is the main content on the website, and then the aside tag means that it's secondary content. It is generally a good idea to use semantic tags when you can, instead of just putting everything in a div or a span. The reason for this is that if you use semantic HTML tags, it's good for SEO because it lets search engines more easily parse the information on your website. It's also good for accessibility because screen readers can more easily navigate pages if you use a lot of semantic HTML tags the way they're supposed to be used, of course. Now with this website layout, I would like for it to be 2 columns on desktop with the main element on the left and the sidebar on the right. And then on mobile, it's going to stack to 1 column with the sidebar below the main content. So at a foundational level, this is what responsive design means. It means making the website design look different if it's loaded on different devices. Now, there are a few components that work together in order for responsive design to work in the browser. And the first one is that you need a specific tag in your HTML head. So let's scroll up to the head of the HTML. And you can see that in our head, we have a meta tag that has a name viewport. So the viewport is the part of the website that you can see in your device. Most websites are longer or taller than your viewport, but then you can scroll down the page to read what's further down. And while the website content is usually taller than your viewport, it's usually the same width as your viewport, unless you have to scroll horizontally to see content that's initially off screen. That's usually not really a desirable design. So usually you want the website to be the same width as your viewport. So this viewport meta tag is doing 2 things. First, it's setting the width of the website to the device that is currently viewing it. So if you're loading the website with a phone that's 375 pixels wide, the website is going to be 375 pixels wide. But if you're loading it from a monitor that's 1920 or 1920 pixels wide, the website is also going to be 1920 pixels wide. So that's what the content width equals device width means. Then the initial scale of 1.0, that means that it'll set the initial zoom of the website to 100% or 1.0. And we can view how a website will look on various devices with an emulator that's built into all browsers. So let's go into our browser, and I'm using Firefox. We can change the device that we are using to view the website by going into the inspector and then clicking on an icon that looks like a phone and a tablet over here. So once we click that, we can select the specific device that we want to use to view the website as. So right now I have iPhone 11 selected. We can see that the viewport is 375 pixels wide, 812 pixels tall. And we can also switch to, say, an iPad view. So now it is bigger. We can see that this is the size of the iPad. And the width of the iPad is 810 pixels wide, 1080 pixels tall. So let's go back to the iPhone view. And let's see what happens if in our code we don't have this viewport meta tag. So I'm just going to comment this out with a VS Code shortcut, Control-K, Control-C, and that will comment it out in HTML. So then we'll save, and let's load the website again. And this is still the iPhone view of the website, and we can see that the text on the website is smaller than it was before. So what's happening here is that the width of the website is not getting set to the device width. So it wants to get a lot wider than 375 pixels. But then in order to fit the width of the entire website on your phone, it's making everything very small, almost like it's zooming out a whole bunch. And this is not what you want for a user experience on any website. If you've ever loaded a website on your phone and it looked kind of like this, where it's super, super zoomed out, it's probably because that website wasn't optimized for responsive design. And so it's probably missing that meta viewport tag. So let's uncomment this, we'll select it, and then again use a shortcut, Control K, Control U, and that will uncomment code in VS Code. And now it looks normal the way it should be on a mobile phone. Now let's set up a new Sass partial for our demo website. If we go up to the SCSS folder, I'm going to create a new subfolder in SCSS. I'm going to call this Layout. And in it, I'm going to create a index partial. So _index.scss. Then since we created a new subfolder, we need to make sure we forward all our layout styles in our main style.scss file. So we'll say forward layout and save that. So when you're setting up your Sass files and folders, you can either try to organize and name them in the way that makes sense to you, or you can try to follow existing architecture patterns like the 7.1 architecture. I'm doing a little bit of a hybrid where I'm using the layout name from the 7.1 pattern, but using the other folder names, globals and util, based on what previous jobs used, and just keep my own preferences. So personally, I think that as long as you keep your styles organized, you don't necessarily have to use a specific architecture. So let's go back into our index.html file and take a look at the markup. So what I'm going to do is use CSS Grid to control the 2-column or 1-column layout. In CSS Grid, you have a grid parent element, and then you have grid child elements. So in our case, the main, and I'm going to just minimize the paragraph tags, the main and the aside elements are going to be the grid children. And if you look at the markup, the parent element of the main and aside is the body tag. Now, I don't really want to set CSS Grid properties on the body tag itself, just in case we need to add other elements to the body later on. So I'm going to move both the main and aside elements into a parent div. So in the body tag, I'm going to create a new div, and I'm going to give it a class of grid. So again, using Emmet and VS Code, we can create that by just saying dot for the class indicator, type in grid, and then press enter. And it's created a div that has a class of grid. And then I'm going to move the aside and the main tags into the grid. So Alt up will move it into the tags. Then we'll save, and Prettier will format the code for us. So this div with the class of grid is going to be the grid parent. And I'm also going to add some CSS classes to the main and aside elements as well. So in the main tag, I'm going to say class, and I'm going to set it to grid __ main. And then for the aside, I'm going to add a class of grid _ sidebar. So these class names having that double underscore might seem kind of strange, which is totally understandable if you haven't seen this type of formatting before. That double underscore, along with how each class begins with the word grid, is part of what's called the BEM, or the block-element-modifier approach to writing Sass styles. So let me show you in the grid.scss file. And actually need to create that file. So in our layout folder, I'm going to create a new partial _ grid.scss. And in the index file and layout, we need to forward grid and save that. And then we'll close the index.scss file for now. So in our grid.scss file, the first thing we're going to add is a selector for the grid class. So that's dot for class and then grid. Then let's add a selector for that main element, which has a class grid __ main. And instead of having to write a completely separate selector for this class, like let's say grid __ main, what we can do actually is use a feature of Sass called nesting. So what we can do is move that inside the actual grid class selector, and then we're going to say replace the grid here with an ampersand. So this ampersand will stand in for the parent selector, which is in this case grid. And then it's followed by that double underscore and then the word main. So we can do a similar thing for the grid __ sidebar. We'll say ampersand, which stands in for grid __ sidebar. And that will be our selector for the sidebar. So how do these class names fit into the BEM model of writing Sass styles? The B in BEM stands for block, and you can think of a block as a standalone component in the design. So in our example here, the grid is the block. And this is this element, the div with class grid. The E in BEM stands for element. And elements are child items contained in the block. And here we have two child items. We have the grid main element and then the grid sidebar element. And in these class names, we're separating the name of the block, grid, from the name of the elements with that double underscore. So that's why we have underscore underscore main and then underscore underscore sidebar. And then the M in BEM stands for modifier. Modifiers are alternate versions of either blocks or elements, and you denote them with a double hyphen versus the double underscore for the element. We are going to use modifiers a little bit later in our demo website. For now, let's just work with the block and the elements. And I remember when I first saw CSS classes like these that were really long, in my opinion, and had that double underscore or sometimes a double hyphen. And to be honest, they looked really weird to me at the time. What was the purpose of writing these long compound names? Well, one benefit to using BEM is that it helps to keep the class names unique so that you don't have style conflicts if, let's say, you have two different sets of styles for a main class selector. And also, if you ever change the name of the block from grid to something else, you only have to change the name in one place in your Sass files, as opposed to having to do a find and replace for any instance of the word grid as a class name. So this is kind of similar to the reason why we use variables. It makes it so that you're not duplicating things where you don't need to, but rather you can reuse them in kind of more efficient ways. And BEM is also useful for my favorite thing, which is organization in the code. You may have noticed that the Sass file itself is named grid, and the block name is also grid. And this is on purpose. It makes it easier to track down where the styles are located in your files. Now we do have the Sass source maps, which we looked at earlier, and those will tell you the original Sass file and the line number where a style rule came from. But it's also good to know that if you have a bug on an element that has a CSS class of grid underscore underscore sidebar, you could sort of guess that you're looking for a Sass file that has a name of grid. The ampersand and the underscores and the hyphens in BEM, they do take some time to get used to, but I personally think that they're more than worth it in the end because it makes working with your styles a little bit more organized and efficient. All right, so before we start writing any more code, let's take a look at what we have so far in our local website and figure out where we want to go from here. So in our browser, and I have the emulator turned off, by the way. In our browser, we have the main element with the Mythos title and then some text. And then underneath that, we have the sidebar with the title, more info. Right now, we don't have any style rules that control the layout of these two elements. We have the main element going all the way across the website, and then we have the aside element also going all the way across the website. And actually, this layout with the main and the sidebar element underneath it is what we want if this website was loaded on a mobile device. However, on desktop view, we wanted that two-column layout to have the main on the left and the sidebar on the right. So we're going to use CSS Grid and a component of responsive design called media queries to make that happen. So first, let's set up the grid. So going back to VS Code in our grid.scss file, let's add a style rule to the grid parent selector that says display grid. And this will essentially turn on CSS Grid and allow it to work. However, this rule by itself is not going to do anything. We also need to set up what we call a grid template, which is the number and size of columns and rows for our layout, and the space between the columns and rows. So let's start by setting the grid template up for our mobile view. And this is one column with two rows. When using grid, the most important thing is to make sure that you explicitly set the columns, since having multiple columns is different from the default of elements going all the way across. CSS Grid is smart enough to add more rows if you have more grid child elements, even if you don't explicitly define them in your grid template. And we'll see a little bit more of that later on. So now, to add the columns, we're going to add a new style rule in the grid parent selector. Grid template columns. And we're going to set this to 1FR. So this is essentially saying that in our grid template, we want one column because we only have one value here. And the FR unit is a unit that's used for CSS Grid. The FR is short for fractional unit, and it's sort of like a ratio where it'll divide the available space into as many columns as you have. So since we only have one column, 100% of that width is going to be given to that column. You'll see a little bit more of the FR unit and how it works when we set up the desktop grid styles. Lastly, I want to add some space between items in the grid. We can control that space by writing another style rule that says gap and I'm going to say 40px, 40 pixels. This is going to add a space of 40 pixels between all cells in the grid. And if you've seen my YouTube videos, you probably know that I generally use the rem unit, not the pixel unit, because pixels aren't as accessible for people who might be using their browser settings to control the base font size. So we will be converting those pixels into rems a little bit later in the video, but for now, let's just use pixels. So this is actually all we need for our grid template. So let's save and then check out how it looks on the website. All right, so it looks pretty much the same, except you might notice that there's a little more space between the two sections. So let's also take a look at this with the grid inspector that Firefox has. And I'm pretty sure that Chrome and Safari have similar tools. So on the right side of the inspector, if we click the Layout tab, there is a grid panel, and we want to select that as well. And in the grid panel, it's going to list all the elements that are using CSS Grid. So right now we only have this one element using the grid class. So if we check that box, it's going to display grid lines in our grid template, and it's going to show us the rows and columns in that grid. One thing to note is that rows and columns are also called tracks. So a track could be a row or a column. So you might see that word used when you see CSS Grid being discussed. And we can also see this shaded space here between the two grid child items, and that is that gap of 40 pixels that we set in our styles. Now, looking at the grid lines, the top horizontal line is solid, but then the bottom line under the second row is dotted, if you can see that. And this is because we didn't explicitly set a second row in our grid template. We didn't set any rows. So even though CSS Grid added that second row or track below the first one, this is what's called an implicit track. So if we go back to VS Code, let's define the grid rows explicitly by creating actual rules for them. So under grid template columns, I'm going to create a new rule that says grid template rows, and I'm going to set this to auto. So auto means that it's going to be sized based on how much content the grid child item contains. So now if we look on our website, I'm not sure why this color changed, but now if we look on our website, we can see that the bottom line of the grid here is now solid instead of dotted like it was earlier. And the lines on either side of the gap are always going to be dotted because the gap space isn't considered a track itself, it's just a space. And you may have noticed that the vertical and horizontal lines of the grid are labeled with numbers. So for the vertical column lines, they start at the left side with the number 1, as you can see here, and then they go up as you move to the right. So that last column line is labeled 2. And the horizontal rows start at the top with 1 as well. And then they increase as you move down. So the top line is 1, the middle line, which is where the gap is labeled 2, and the last line at the bottom is labeled 3. So these line numbers are helpful to determine the position of each cell in the grid. The top cell contains the main element. This is between column lines 1 and 2, and it's between row lines 1 and 2. And the bottom cell with the sidebar is between column lines 1 and 2 as well, and it's between row lines 2 and 3. Being able to identify a cell in the grid using the line numbers comes in really handy when you have bigger and more complex grids with multiple rows and columns, and you want to place some content in a specific cell in that grid. It might be different than what's considered default, like what we have here. We'll get more into this a little bit later in the course. And you might be wondering what these negative numbers are as well. We can see there's a -3 on this top line, -2 and -1. And then for the column lines, there's a -1 and -2. The positive numbers are if you're starting from the beginning, meaning the top for the first row or the left side for the columns. But you can also number from the opposite side, so the end. So we could say the top line is also -3 because it goes from 1, 2 to 3. And then from the bottom, it goes -1, -2, -3. And in the same way, the column lines go from 1 to 2, but they can also go from -1 to -2. These are different names for the same thing, and it helps more when you have more complex grid templates, and it's easier to locate a cell based on the end or like the bottom right-hand part of the grid template. All right, so now that we have the mobile layout working, let's set up the 2-column layout for desktop. So going back into our styles, I'm going to add some background colors for the main and sidebar elements just so we can differentiate them a little bit more easily. So in the grid __main selector, I'm going to add background color and set it to blue. Then I'm going to hover over that color swatch in VS Code and then select the sort of darker blue color. And I'm also going to switch to HSL color format. Then I'll do a similar thing for the grid sidebar. So background color, and we'll start with magenta. Oops, magental. And then I'm also going to hover over that and make it a darker color. And set it to HSL as well. Let's also add some padding to both the main and sidebar elements. So I'm going to create a compound selector. So we're going to say ampersand underscore underscore main, comma, ampersand underscore underscore sidebar. So in this compound selector, I can add padding to both elements at the same time with just that one rule. So we'll say padding 40 pixels. Okay, let's look at our website. So now we can see the two colors of the elements, and there is some space between the text and the edge of the page now, which gives a little bit more breathing room. It's a bit more comfortable to look at. So let's go back to our styles. So what we need to do is we want to change the grid template from one column to two when the website is viewed on a desktop computer. So in order to add that logic in our styles, we're going to use what's called a media query in our parent grid selector. So media queries start with a @media, @rule, and then they're followed by a media feature, which lists the conditions that need to be met in order for the style rules in it to be applied. So in Sass, unlike pure CSS, we can actually start writing the media query right inside the selector itself, which you can't do in pure CSS. In pure CSS, you'd have to write the @media rule outside any selector, and then inside it, you would add your selector in again. So this is another instance that Sass makes things a little bit more easier than pure CSS. So what conditions do we want to write in our media query? Well, in our case, we want to change the styles based on the width of the viewport of the device. So we need to decide what width we want to start displaying the content in two columns as opposed to one column on mobile. So I'm assuming here that most phones are around 375 pixels wide, tablets are around 800 pixels wide, and then small screens are going to start around 1024 pixels. And of course, larger screens are going to be bigger than that. So for our main and sidebar elements, I'm going to say that I want the two column layout to start happening for devices that are 900 pixels wide and up. So this will make it one column on mobile and on portrait mode in tablets, and then two columns for landscape tablets and screens. The width that we want to change the design at is called a breakpoint, since the design breaks and then is different after that point. So in our media query, we would write that by adding, in parentheses, min-width, colon, and then the actual width. We're going to say 900 pixels for now. Then we're going to add curly brackets, kind of like any other style rule. And in the curly brackets, we'll write our new styles that will then take effect on devices that have a viewport width of 900 pixels and up. Now you can also write max width as opposed to min width to target viewport widths that are a certain number and smaller. Also, another thing to note, I am using pixels right now. It is better to use an accessible unit, kind of like EMs, for media queries instead of pixels. The reason for this is because we want to allow users to scale up the text on a website by changing their browser-based font size, and using pixels prevents that ability. But again, we're going to be converting these pixel values to EM units a little bit later on in this section. Now, in the curly brackets, we want to change our grid template. Since we want two columns, we want to say grid template columns, and we're going to give it two values as opposed to the one value of 1FR up at the top for mobile. Now I'm going to set it to 2FR, 1FR. And this is again using that fractional unit to determine the width of each column. So what 2FR, 1FR means is that the first column, which is going to be the main content, is going to be 2 times as wide as the sidebar, the second column. This is because the FR units kind of relate to one another. So we can actually see that in action. So we've saved, and let's check out the website. So now if we move our inspector panel wide enough, we're going to trigger that breakpoint happening at around 900 pixels wide. Now let's check out the width of the elements. So the main is about 601 pixels wide, and then the sidebar is 300 pixels wide. So we can see that the main is about double the width of the sidebar. So you can see in our browser how I'm sort of sliding that inspector panel narrower to sort of emulate a mobile width where the content goes to one column. And then I'm sliding it over back to the right to emulate, a desktop width. So this trick of using the inspector panel to change your viewport width as you're loading the website is pretty handy when you want to test your responsive styles. Now the inspector is also going to show you the different rules taking effect. So let's click on the grid parent item. And we can see the rules that are currently in effect are, right now it's 2 columns. So we can see this is the media query that we just wrote, media min width of 900 pixels. And then the grid template columns has those 2 columns of 2FR and 1FR width. And if we bring it back to narrower to show the mobile styles, it's showing the grid template columns of just 1FR and the media query isn't there. So going back to the desktop width, it shows us the default rules that we have. But you can see this grid template columns of 1FR is crossed out because we have the media query of grid template columns. And so that's more specific, which is why it's taking effect when the viewport is 900 pixels wide and up. Let's also check out the grid inspector tool. So again, you can see that we have that gap between the columns. However, there's also a gap below the first track. Why is this happening? Because this shouldn't really be the case, because the gap property in CSS Grid only adds space between actual tracks in the grid template. And we don't have any other content other than the main and the sidebar. So the reason this is happening is because we have the grid template rows property that we added to our default grid styles, and it's set to auto. And this rule is still affecting desktop widths, even though there's only one row, because we haven't set a different rule in the media query for desktop widths. And this is one thing to keep in mind, that the styles outside the media query are what's considered the default styles. And styles in the media query will add new rules and also override any default styles if they're using a different value for the same property. So what I want to do is I want to override the grid template rows auto inside the media query for desktop. So if we go back into our code, inside the media query, we'll add another line, grid template rows, and I'm going to set that to just auto. So this will mean that for 900 pixels wide and up for viewport, the grid is going to have just one row and it'll be set to auto. So now when we look in the website with the grid inspector, and for some reason it always keeps changing the color, but now when we have the grid inspector view on, that extra gap below the track is not there anymore because the grid template now explicitly only has one row set up. So going back to VS Code, I wanted to mention one more thing about media queries. So you may have seen media queries where they're using both a min width and a max width in the media features. It could be something like this media min width 900 pixels and then in parentheses something like max width 1920 pixels. And what this would do is this style rule is only going to apply if the device viewport is between 900 pixels and 1920 pixels. Now this might seem like a good idea because it looks like you have more control, setting min width and max width in your media query. But this can actually end up overcomplicating your styles, because if we have this rule, we would actually have to create another media query for device viewport widths that are greater than 1920. And this is kind of what people used to do a lot when responsive design was a little bit newer. We thought that we had to create an individual media query to target every possible device width. So imagine how many different, phone sizes and tablet sizes and even screen sizes there are. That would be a lot of media queries for just, one set of style rules. And then you think about imagining all the other style rules in your website, and that adds up to a whole bunch of style rules that you may not really need. For example, you might have targeted styles between 300 and 640 pixels for mobile, somewhere between 640 and 1023 for tablets, 1024 to 1440 pixels for screens, and then 1440 pixels and on up for even larger screens. But, having all those different media queries, it's not really going to make a difference in how this design of our grid template is working. Because all we're doing here is we have one column for mobile and then 2 columns for anything that's bigger than mobile. So we really just need one breakpoint set between where we want the 1 column and 2 column layouts to be. And I've arbitrarily kind of chosen this 900 pixels breakpoint, knowing that most desktop screens are going to be larger than that, and then all mobile devices are going to be smaller than that. So when you're creating your media queries, don't feel like you have to create a set of media queries with rules for every possible device type. Instead, look at your design and create your media queries based on that, depending on where you think the design needs to change. So what I usually do is, let's say I have some styles that I want to be different between mobile and tablet devices, then I would create a breakpoint that has a width that's somewhere between mobile and tablet viewport widths, which might be like 700 pixels, knowing that mobile phones are going to be narrower than 700 and tablets are going to be wider than 700. And then if I have a layout that's different for desktop screens versus mobile and tablet, then I'll do what I did here and create a breakpoint that's, somewhere around 900 or sometimes even 1,000 pixels wide. Another thing to remember when you're creating your breakpoints is just try to keep consistent widths. So for example, I'm using 900 pixels for my breakpoint for desktop, and I'm always going to try to use 900 pixels when I can, if it works. So I wouldn't set, 900 pixels for one media query and then 950 pixels for another set of style rules, because then you're going to have things sort of changing at different breakpoints and it might look a bit strange on your website. And the other thing I get questions about sometimes is, why do I only use min-width media queries and not max-width media queries? And again, you can totally use just max-width media queries if you want. It's just going to be, different than the way that I am doing it here in this course. The reason that I personally use min-width media queries is that mobile styles are usually less complex than desktop styles, meaning desktop styles are going to usually have more style rules than you have on the mobile styles. So by using min-width media queries, my default rules up here are going to be the mobile style rules and everything else. And then for desktop styles, if I want additional style rules, I can add them in the media query, and they're not going to affect the mobile styles because we're using that min-width media query breakpoint. If I was to use max-width media queries for all my style rules, that would make the default styles desktop styles, and then I'd have to add more rules to sort of cancel them out for mobile and tablet devices, which will result in a whole bunch of rules that you don't really need to write. So this is just the way that I do it. You can obviously find whatever approach works best for you, but I'm just kind of explaining why I like to use min-width media queries whenever possible. And I will sometimes use max-width media queries if the mobile styles are more complex and require more rules than the desktop styles. I just generally try to not mix both min and max-width media queries in your styles too much, because it can cause some conflicts if the breakpoints don't hit the same across all browsers. But I usually use min-width, sometimes max-width when I have to. I just try not to mix them too much. All right, so hopefully that you can see how using CSS Grid is one way that you can make a website responsive. And we could actually use Flexbox to create the same 2-column layout if we wanted to. Now, before responsive design was really big, websites were generally built to a specific static width, like 1024 pixels wide, because most monitors were that size. So it was okay to set things to, that static width of 1024 pixels. But that obviously wouldn't work very well today because we have devices that are all kinds of different sizes. So generally try to avoid setting static width for things, especially for layout styles like our 1-column and 2-column layout rules. So for example, that's why we like to use these fractional units, because they're relative to whatever device you're using. It's not that static width. And aside from Grid and Flexbox, another way to make a layout responsive is to use the max width property. For example, our website right now is going to take up 100% of the width of the browser. So if you have a really large screen, text is going to be really wide, and it's not really great for readability purposes. So if we wanted to limit that width, we could do something like set a max width on the grid parent selector. So max width. And let's say we'll just set it to 1000 pixels wide. So the content's not going to go, super wide, even if you have a really large screen. So let's save that and check out and see what it looks like. So On mobile widths, the website is still going to be 100% width of the device, which is, generally what you do want. Then as we get wider, you can see that the width of the content, it sort of stops at this point. It doesn't go any wider, even though our screen has become wider. But on this larger viewport, the website's only on the left side of the browser with all this extra space on the right, and that's not really desirable. Ideally, we want to center it so that there's equal space on both sides. So one way we can do this is in the grid parent selector, we can set the margin left to auto and margin right also to auto. So what this does is setting both margin left and margin right to auto is going to center the content on the page, since the auto value lets the browser sort of decide what the value should be. And what you can also do is, instead of margin left and margin right, you could use a shorthand property of margin and set it to 0 auto. So what this is doing is it's going to set the top and bottom margins to 0, and then it'll set the left and right margins to auto. So if we save that, again, we see the website is centered. And just as a quick refresher, if you're using the margin shorthand property, it can take up to 4 values. And if you use all 4, let's say we did 0 auto, 0 auto, the order does matter. So the first value in the margin shorthand is going to be margin top, and then it kind of goes around like a clock. So the second value is going to be your margin right property, third value is going to be your margin bottom, and the fourth value is going to be the margin left. And you could even use 3 values. So you could say 0 auto 40 pixels. And what this is going to do is it's going to set the margin top to 0, margin right to auto, margin bottom to 40 pixels, and it'll also set margin left to auto, even though we didn't say auto again. You can see that if we check this out. Here we go. So margin 0 auto 40 pixels, and we can expand it so it actually tells you what this ends up being. So margin top 0, margin right auto, margin bottom 40 pixels, and margin left auto. However, even though this shorthand is kind of nice because you don't have to write out, all the specific margin properties, you can sometimes run into issues when you're using it. For example, if we're saying margin 0 auto, and we don't actually want to set the top and bottom margin to 0, we just had to put the 0 because you have to do that when you're using the margin shorthand property. And we had to do this because for a long time, there was no way to only set margin left and margin right without also having to set top and bottom with this margin shorthand property. So you'd have to set the top and bottom to 0, but at some point, depending on your styles and your website, you might have to manually cancel it out and change the margin top and margin bottom values in your different styles. And this is a little bit inefficient just because we don't actually have to set margin top and bottom here. All we're trying to control is margin left and right. So then you'd have this rule, and then you'd have to have additional rules later in your styles to change the margin top and bottom. However, there is now a new margin property called margin inline, which I discovered through Kevin Powell. Margin inline lets you only set the left and right margins, which is what we're trying to do here, and it's not going to affect the top and bottom. Now, it is called margin inline because it's setting margin inline start and margin inline end. So margin inline itself is kind of a shorthand property for the margin inline start and margin inline end properties. And they're using this kind of wording of start and end because it can change depending on your writing direction. So in the Western world, we're usually going to go from left to right, but in some countries, you might go from right to left. So that kind of enables you to have control over the start and end versus having to set left and right. So with this in mind, we can say margin inline and simply say auto. And let's see what this looks like on the website. So now in the grid, it says margin inline auto, and it's only set the margin inline start and margin inline end. And we haven't set the margin top and bottom. So this is kind of a newer property, but it really gives us this extra control that we've been wanting for probably years at this point. Now there is another method that you can use to center the content. We could also use CSS Grid to do this by making the body element, which is the parent of the grid element. So we can see here we have the body tag, and inside the body we have the grid class element. So the grid is a child of the body tag. So what we could do is make the body tag also a grid parent and then center the content in the body. So we can do this by going back into our boilerplate Sass file, and I'm just going to add display grid. And to center the content in the grid, we'll say justify content center. So what this does is it's going to center the content horizontally. The technical term for this is the inline axis of the grid, which is going to be the horizontal axis. You can also center vertically with CSS Grid. That's what's called the block axis. I don't really see those terms getting used very often, but they are the technically correct terms. Usually I just think of justify content as, horizontal alignment. So let's just see how this looks in the website. I need to comment out the margin inline rule. So now there's nothing centering using margin, but we have the body as the grid parent, and then it has the centered content for justify content. So now here's the website. And then if we go to bigger widths, again, it looks like it's centered, which is great. You can also, if you wanted to, do this same thing with Flexbox. So we can set the body to display flex, and it also uses a justify content property. And if we look at the website, again, it is centered. And here we can just make sure. We need to. So if you look at the website again, we want to select the body tag, and it has display flex and justify content is centered. So there's a couple different ways that you can achieve centering the content. I personally like using the margin property to center, just because we can accomplish that with that one style rule of margin inline, and we don't need to set anything on the parent element, the body tag. So we'll go back to what we had before, delete those rules from the body, and we're going to uncomment the margin inline rule, so it should be taking effect. So now, just to make sure it's working, looks like it's centered, which is good. And we have the margin inline rule taking effect again. And I did also want to show you a sort of newer, maybe slightly more advanced way of limiting that max width. So if you remember, we set the max width of the grid parent element to 1,000 pixels. There's a newer way that I discovered from Kevin Powell. And if you aren't following Kevin on YouTube, I seriously cannot recommend his channel highly enough. Just because he's really good about staying up to date on that cutting edge of CSS technology, and he goes really in depth into his content. So I personally have learned a lot from him, and he's an excellent teacher, so highly recommend his channel. So this newer method is using something called min. It's a CSS function. And then we're using that in conjunction with margin inline to center the content. So let me show you what this looks like. So instead of max width, I'm just going to comment that out for now. We're going to say width, and then we're going to use this min function. Now, what does this function do? Well, what min does is that it takes two parameters separated by a comma, and it's going to choose the smallest value between the two. So it's sort of constantly monitoring both those parameters, and it's going to use as a final width whatever the smaller number is. So we can apply this to our grid container. So on mobile, we want the grid to go all the way across to 100% width, but on large screens, we don't want the content to be bigger than 1,000 pixels. So we want the value to be somewhere between those two values. So let's see what happens when we set the width to min 100%, because that's what we want for mobile, comma 1,000 pixels. So going into our website, we have the grid selected. So you can see we have the width, and it's using that min function here. So we want to see the actual sort of calculated width, so we can go to the computed tab. And it's going to tell us the final calculated width in the browser. So right now it's saying width is 811 pixels. And that's because 100% of the device viewport width, which is currently 811 pixels. 811 pixels is less than the 1000 pixels as the second parameter, so the browser is going to choose the 811 pixels. Now, if we make this wider, and let me actually dock to bottom for the inspector. This will make it a bit easier to look at this. So now our viewport width is, let's see, if we select the body, 1262 pixels wide. And in the grid, if we look at the computed tab again, what's the width? The width is going to be only 1000 pixels, even though our viewport is greater than 1000 pixels. So this is what the min function can do. It kind of has this sort of intelligence that it'll allow the browser to pick, a certain value between those two numbers, which is honestly pretty cool. And we can do one more cool trick here. If we look at the mobile view, you might not always want the content to go all the way to the edge of your browser. You might want sometimes a little space so it can breathe a bit easier. So let's say I wanted to add 20 pixels of space to the left and the right of the content. What I could do to do that is I could add maybe padding left of 20 pixels and padding right of 20 pixels to the mobile view, to the rules. And then if we reload the website, we have that space on the left and right. However, if we do that, for desktop widths, let's see what this looks like here. I think this affects so it's going to affect the desktop width of the content. So we have the grid here, and this is making the actual width of the content 950 pixels because it's subtracting that padding from the left and right. And, let's say you really wanted the content width to be 1000 pixels for desktop. So what we'd have to do in that case is cancel out the padding left and right rules in our media query. So we'd have to say padding left 0 and padding right 0. Then for mobile widths, it would be, 1000 pixels wide for desktop widths. But this is kind of what I was mentioning earlier, where you sometimes have to cancel out rules for going from between mobile and desktop. So I could try to fix this by saying media max width, let's say maybe 899 pixels, so we don't run into the 900 pixel rule here. And then we could just add the padding there in our mobile media query, and it wouldn't affect the desktop style, so then we wouldn't have to cancel them out with additional rules. So you can see again, it's working. The content is set at 1000 pixels, and then it adds that padding. This isn't really desirable because, we're having to add another media query, a max width media query at that, to our style rules. And there is an easier way, which I'm going to show you, which is pretty awesome. So the quicker way that we can make this work is actually right in our min function that we're using right now. So the problem for mobile is that we don't actually want the content to be 100% width, right? We want it to be 100% width minus that 20 pixels on the left and the right sides. So what we can do here is, in the first parameter, where the mobile view is using 100% width, we can actually say 100% minus 40 pixels. And what this is going to do is going to add space that will be that 20 pixels on either side. And because we have margin inline set to auto, it's going to be centered. And it won't affect the 1000 pixel width of the content for desktop sizes. So let's check it out, make sure that this is working. So here we have our mobile view, and we can see that we have that padding added from the width min of 100% minus 40 pixels, which is pretty cool. Let me just select this just to make sure everything looks okay. So you can see here the extra space is because the width is not 100%, it's 100% minus 40 pixels. So it has this 20 pixels of width on both sides. Then as we get bigger in our viewport, we can see that it's centered, but the space is still equal on both sides. And let's go back to dock to bottom. it's telling us that the grid content is still 1,000 pixels wide. So the extra space that we added, unlike the padding property, is not cutting into the 1,000 pixel width that we want the content to be at. So this is a pretty cool rule that I actually learned semi-recently from Kevin Powell. And I think it's really handy. So, I've just shown you 4 different ways that you can center the content on desktop and then also control the width. I'm showing you these different ways of accomplishing the same thing because that's kind of how it is in the real world. There's usually not one 100% right way of doing something, but there's multiple ways that you can make something work, and the end result will be pretty much the same. So for a lot of things, it's really kind of going to be up to you to decide what you like better, what you feel like is the most efficient way of writing your styles. And honestly, as long as the code is understandable to other developers, and it's responsive, and it's not taking up a ton of lines of code, in my opinion, you can just choose whichever way makes the most sense to you. So I do want to note that I am using Flexbox and CSS Grid in this course, but I would not consider this course to be a comprehensive Flexbox or CSS Grid course. If you want a deeper dive into Flexbox and Grid, I highly recommend Wes Boss. He has free courses on both Flexbox and Grid, and also Kevin Powell's YouTube videos. And you can also go on the website CSS Tricks. They have a really great guide for both Flexbox and CSS Grid. All right, let's go back into our styles and look at some more Sass helpers that will make writing our code more efficient. So I'm going to use what's called a Sass mixin to rework our media queries. Mixins in Sass are bits of style rules that you can create and reuse in your styles. They're sort of like variables because they let you type out shorter code instead of having to manually write things out the long way all the time. So we're going to create a mixin that we can use every time we want to write a media query. So first off, I'm going to go into my files, and I'm going to create a new Sass file in the util folder. And I'm going to call it breakpoints.scss. And again, since we're creating a new Sass partial, I'm going to go into the index Sass file in util and forward breakpoints, so that it'll load our breakpoint Sass file. So in our breakpoint Sass file, I'd like to save the breakpoint width so that I don't have to remember all the numbers all the time. And what I'm thinking is to have 3 different breakpoints, one for mobile, one for tablet, and one for desktop. So mobile devices will be at 700 pixels. So let's just write this in the comment here, 700 pixels. Mobile devices will be 700 pixels and less, and then tablets will be between 700 and 900. So we'll add 900 as the next breakpoint. And then small monitors are going to be between 900 and maybe 1440 pixels. And then large screens will be 1440 and larger. To save these values, we're going to use one of the built-in Sass modules called Sass Map. These built-in modules are functions and other things that just come out of the box with Sass, so they're pretty helpful. So with Sass Map, you can save data in key value pairs, similar to an object in JavaScript or other programming language. So this might sound kind of complicated, but what it boils down to is that I want to set widths smaller than 700 pixels as small. I want to say widths between 700 and 900 are going to be called medium, and then widths between 900 and 1440 pixels will be called large, and widths greater than 1440 pixels will be called X large. So that way, when I'm writing media queries, I don't have to remember the actual number, but I can just use the sizes, small, medium, large, and extra large. So let's make our Sass map. So I'm going to call this map breakpoints up. And to create a Sass map, we're going to do similar to when you're creating a variable in Sass, and it's going to start with a $, and then the name breakpoints up, add a colon, and then we're going to add stuff in this parentheses. So in the parentheses, we're going to start adding the keys and values. The keys term is a programming word that means the name or the property that we're going to be giving a value. So with min-width media queries, our mobile styles are going to be the default styles and then don't require a media query. So the first key is actually going to be medium, which we will save as a string in quotes. Then add a colon, and then we're going to add the value, which is considered a number in Sass, so it doesn't need quotes. So the medium breakpoint is going to be 700 pixels. Now, the medium breakpoint is 700 pixels, but if you remember, we actually don't want to use pixels, but a relative unit. Now, while I did use the rem unit for setting fonts and other sizes, when I did research on the best font for media queries, it seems like the EM or M unit is the best for those. You can use rems, but there were apparently some bugs in Safari for them if you zoom in on the browser, so I just use M units. So to get from pixels to M units, one EM or M is calculated relative to the parent element. For media queries, an M unit will be based off the browser's base font size. The base font size is by default 16 pixels, making 1M equal to 16 pixels. So to convert from 700 pixels to M units, we're going to pull out our calculator and we'll divide 700 by 16 to get 43.75 EMs. So instead of 700 pixels, we'll type 43.75 EMs. Then we'll add a comma at the end of this. So after medium, we're going to have large. And large is going to be 900 divided by 16 to be 56.25. And then the last key is going to be X large. And that's going to be 1440 divided by 16, which is 90. There we go. And you see the prettier change my double quotes to single quotes. Okay, now that we have our Sass map for the min width breakpoints, let's create the mixin that we're going to be using to write our media queries. So we'll do this still in the breakpoint Sass file. So I'm going to create a new mixin by using the Sass @ rule at mixin. Then I'm going to name the mixin breakpoint and add curly brackets. So then in the curly brackets, we're going to add the media query that we want to write. This is the code that the mixin is going to generate every time you use it. So when we use a breakpoint mixin, it's going to generate at media and then min width. So it'll be just like the other media query that we've been writing. But then how do we get the breakpoint values from our Sass map up here into our media query when we write, medium, large, or extra large? So to load a value from the Sass map, we can add the Sass function map_get, where we would normally type in the breakpoint width here. So map_get, it's a function, so it has parentheses. The map_get function will take two parameters: the name of the Sass map that we're loading data from, so in this case it'll be breakpoints up, and then the name of the key that we want to load the value from. So the first parameter is going to be breakpoints-up, add a comma, and then the second parameter is going to be, it could be medium, large, or extra large. So since we want to keep this option open, we can load the key name as another parameter of the mixin itself. So in the breakpoint mixin, we're going to add parentheses, and then in here we'll add a parameter called $size. And then this size parameter is what we'll use as the second parameter in the map_get function. This way, when we use a mixin in our styles, we'll have the ability to say either medium, large, or extra large to load whatever breakpoint value that we want. Then, lastly, in the media query itself, we're going to write at content. And this is going to load all the style rules in the mixin itself when we're using it. Now, if this is the first time that you've used mixins, I can totally understand how this can sound very confusing and complicated. But let's use the mixin in our actual styles, and I'll point out where each part is coming from. So back in our grid.scss file, we're going to update the media query for that grid parent element. So instead of saying at media min width 900 pixels, we're going to load the mixin with another Sass @ rule called at include. And then we'll write the name of the mixin, so breakpoint. And then the parameter is going to be what we set as 900 pixels, which is large. So let's save. Now, looks like we got an error, so let's check out and see what's going on here. So our Sass compiler extension says undefined mixin. I'm assuming this is breakpoint large. And then in the gulp, it has the same error, undefined mixin for the breakpoint large. So this is kind of similar to Sass variables because we need to load that util Sass modules in the grid Sass file itself, similar to what we did in the boilerplate styles. We had to load use util. So I'm going to do the same thing. I'm going to copy this from our boilerplate Sass file. And in our grid Sass file, I will put it in at the top. Then when we're loading our mixin, we need to add the namespace, so u.breakpoint. Okay, so now it says success. We don't have the error message anymore, and let's look at how this looks in the browser. So using our panel, we'll slide it over, and it looks like it is still going from 1 column to 2 columns, which is great. And if we click on the grid element, we can see that the styles are loading the media query. And instead of the 900 pixels that we originally had set manually ourselves, it's saying min width is 56.25 EMs, which matches our breakpoints. And we loaded large, so that's why it's loading 56.25 EMs. So this means that our mixin does work. So let's look back in our code and trace how that mixin is getting loaded. In grid.scss, we're using include to load the mixin called breakpoint, and we're using the parameter of large. Then let's go look at the mixin itself. So in the breakpoints.scss file, we are loading the breakpoint mixin, which will create this media query, and it's going to load the value for whatever the parameter was, which was large. So that's 56.25 EMs, and that's going to be the value of this map get function. So going back to grid.scss, for widths of 56.25 EMs or 900 pixels wide and greater, the style rules for having 2 columns, which we wrote earlier, is going to override the 1 column grid style rules up at the top. Now, I did want to point out one big difference in writing media queries between Sass and CSS that I did briefly mention earlier. In the Sass file, we're able to write the media query directly inside the selector that it applies to, but in pure CSS, this would not work. The CSS syntax for media queries is kind of the opposite of in Sass, where the media query at rule can't be nested within the selector, but the selector itself is nested inside the media query. So let me show you what I mean. In the final CSS file that we have generated in the dist folder, I'm going to open that. I'm going to hit save to trigger Prettier to run, so it'll format the minified CSS into more easily readable format. If we scroll down to the grid selector here, we can see that first we have the mobile rules with the 1 column grid template. And then after the grid selector is closed, we have our media query here with the min width set to 56.25 EMs. And inside that, we have another grid class selector with the grid template columns property for the desktop 2 column layout. So this is another way that you can see that Sass is just a little bit more efficient than writing pure CSS because you don't have to write out the selector another time for the media query. Instead, you can simply nest the media query, or in our case, the mixin that we're using to load the media query inside the selector itself, so you're not writing duplicate code. So our breakpoint is going to create a min width media query that we need. But there are some instances where I might want to use a max width media query if there's more mobile style rules than for desktop. So one example of this is in our demo website. Let's say we wanted to have the sidebar text centered only on mobile and not on desktop or tablet. So what we'd want to do is add a style rule saying text align center for mobile. And since we wouldn't want to use a text align rule for tablet or desktop, they would just use a default left align. If we used a min width media query for this, we'd have to, in our sidebar selector, we'd have to set text align center with our default styles, and then we'd have to add a media query to cancel it out, basically. So include breakpoint for tablet and desktop, so we'll say medium for medium and up. And then we'd have to say text align left, even though this is the default text alignment. Oh, I forgot the namespace. So u.breakpoint. There we go. So now we can see, if we look at our sidebar, you can see that the sidebar text is centered. Or actually, we want to center it on tablet too. So we'll say large to match the large that we have for our grid template. So now on the website, we can see that for mobile, when it's one column, the text here is centered. And if we go out to desktop widths, the text is then left aligned. So this is slightly duplicate, but instead of this, let's say we wanted to use a max width media query, we could say, we could delete this whole thing and say at media max width, and then we'll say whatever the medium breakpoint was, which was 43.75 EMs. Or I'm sorry, the large, which is 56.25 EMs. And then move our text align center there and save that. So what this is doing is it is setting text align center for devices that are 56.25 EMs or 900 pixels and down. So the max it could be is 56.25 EMs or 900 pixels. Let's just make sure this is working. So left align for desktop, which is good. And then when it's on one column, it is centered, which is what we want. So this is one of those cases where using a max with media query can save you a little bit of time. I know this might seem really minor because it's just, one extra line of code, but there could be cases where you have multiple style rules that you only want on mobile and not on desktop. So in those cases, a max with media query is going to save you some time. So let's create a new mixin for this. So going back to our breakpoints.scss file, we need to create a new Sass map for the max width breakpoints. The reason for this is we need a slightly different set of pixel width so that there won't be any overlap in breakpoints. Otherwise, you might have some weird behavior on the website. So our breakpoints up map use 700, 900, and 1440 pixels. I'm going to create a new set of breakpoints for the down. And those are going to be 699.98 pixels. So it's 0.02 pixels less than 700. And we'll do the same thing for the other widths. So instead of 900, it's going to be 899.98 pixels. And instead of 1440, it'll be 1439.98 pixels. And the reason for that 0.02 difference is it sort of avoids that overlap the best way possible. And I got the 0.02 number from researching how Bootstrap does it, and this is what they've used. So I'm doing the same thing here. So our Sass map is going to be called breakpoints down. And then in here, we're going to add keys for small, because we might want small and down for 700 pixels and down. And we're going to have to use our calculator again. So 699.98 divided by 16 is 43.7485. So 43.7485 EMs. Then medium and down. And medium is going to be 899.98 divided by 16, 56.24875. 24875 EMs. And then large and down is going to be 1439.98 divided by 16. And that's going to be 89.99875. 89.99875. Is that right? 89.99875. Yes. EMs for large and down. So with this breakpoints down, which is going to use the max with media queries, the default styles are going to be desktop styles and up, meaning large desktop styles and up, meaning larger than 1439.98 pixels. And then we'll gradually get smaller and smaller. Okay, so now that we have our new Sass map, what we're going to do is create our new mixin. So I'm going to create a new mixin called breakpoint dash down. And like the other one, it'll have a parameter of size, curly brackets, and then in the mixin, we'll generate a media query. And instead of min width, it's going to be max width. So max width colon map dash get. And instead of breakpoints up, it's going to load breakpoints down, comma, size. Then here, again, it'll load the content. Okay, so now we can use this mixin in our sidebar styles. So going back to grid.scss, we can replace this max width media query with our mixin. So at include u dot breakpoint dash down, and the parameter is going to be medium and down so that it will text align center for small and medium widths. So let's save that and let's see if it works. All right, so we got our sidebar, and the sidebar text is left aligned for desktop to column, which is good. So as we bring this narrower, it is now centered when layout breaks to one column, which is what we want. And there's one interesting thing to note. You might notice that in the rules, the media query says max width of 56.2488 EMs, which is slightly different from what we had. 56.24875. So it's sort of rounded the 875 to 88. So this is just something that the browser will do. It'll kind of slightly round numbers, that are past a certain decimal point, I believe. So just to illustrate why we have that 0.02 pixel difference in our breakpoints down map, let's try changing the medium value to instead be 56.25 EMs to match what we have in the breakpoints up map. Save that. So now we have both breakpoints up and breakpoints down using the same 56.25 EMs. So when we save that, if we slowly slide this panel over, let's find that point right where it changes. So you might see very slightly, there's a tiny little viewport width where the layout is two columns, but the text in the sidebar is center aligned, which is not what we wanted. We want it to be left aligned, but this is why we need to have that 0.02 pixel difference. This is an edge case because that sort of weird overlap only exists at basically 1 pixel specific width. But you never know how a user is going to load your website. So ideally you want it to be consistent across any viewport width, even 1 pixel difference. I used to do a 1 pixel difference in the Sass map instead of 0.02 pixels, but I noticed that it also caused the media query to trigger about 1 pixel too late when narrowing the viewport. Again, these issues are pretty small. It's not going to be, world ending or everything, but it might come up if you're using this, in an environment and someone just happens to load it at that perfect viewport width where things are looking a bit strange. So just know that the 0.02 pixel difference in your breakpoints up and breakpoints down, Sass maps might be the best way to go. So let's return this to the way it was with that 0.02 pixel difference. So now we shouldn't have that weird little overlap thingy. So you can see it's left aligned and it goes right to center aligned exactly when it goes back to 1 column. All right, so one more thing that I wanted to mention is that if you have multiple media queries for a selector, the order is very important. So to illustrate this, let's experiment with giving the main content different background colors at different viewport widths. So we'll start with the blue background color that we already have here for mobile. Then let's create a new breakpoint for medium and large. So we'll say include u.breakpoint medium. And for here, we'll set the background color to green. And again, I'm going to hover over this color swatch and then select a darker green color. And then change it to HSL. Okay, then we'll add another one, include u.breakpoint large, and we'll set background color to orange. Maybe we'll make that a bit darker again. Oh, and then change it to HSL. Okay, so we'll save that. So what we want to happen is for mobile widths, it's going to be blue. Then when we hit that medium breakpoint, which is 700 pixels wide, it's going to change from blue to green. And then as the viewport keeps increasing, the background color will change to orange once we hit the 900 pixel width. So let's check our website and see if that's indeed the case. All right, so we got the main and it's blue right now. You can see the rule, background color is blue. As we increase the viewport, it switches to green at this 43.75 EMs or 700 pixel breakpoint width. And then as we keep increasing, eventually it will change to orange at 56.25 EMs or 900 pixels. So this is working because in our styles, it's saying, viewport width of 700 pixels and up, set the background color to green. Then on top of that, it's saying for viewport width of 900 pixels and up, change it to orange. So our default is blue for mobile. And then we kind of add on, and then at 700 pixels, change it to green. And then on top of that, at 900 pixels, change it to orange. But what happens if instead of having it be, mobile as our default styles and increasing, going from medium up to large, what if we put this in the wrong order and we put the large media query before the medium one? So let's look at our rules really quick. So now our rules are saying, okay, background color is going to be blue, but then at viewport widths of 900 pixels and up, we want it to be orange. But then on top of that, at 700 pixels and up, we want the background color to be green. So if we have this as our rules, you can kind of make a little guess here. What do you think the background color is going to be for desktop widths and up, meaning 900 pixels and up? So let's look at our website and see. And if you thought green, then you'd be correct. So why is the green background color happening for desktop widths? And we can see that it's green all the way down until we hit that, hit the mobile widths again, which is, I'm assuming, 700 pixels and down. The reason this is happening is due to what we call the cascade in our styles. The cascade is kind of how CSS determines what styles will ultimately be used on a website for any given selector. And this is why CSS stands for cascading style sheets. So the cascading part means that if you have two rules that are the same specificity level, and these rules all are the same specificity since they're for the same selector, the grid __ main selector. The cascade means that for rules that are the same level of specificity, the later rules, which are farther down in the style sheet and occur later, are going to override rules that are before them. So what's happening here is the background color orange for large is getting overridden by the background color medium because large starts at 900 pixels and up, right? But it's getting overridden because medium starts at 700 pixels and up, and it completely overrides everything, including the large, above 700 pixels. So usually when you're writing rules for min width media queries, you want your media queries to get larger as you go down your style sheet. So this is why we have medium first, and then we have the larger viewport width coming after that. So you're adding large onto the medium breakpoint. So just for illustration purposes, let's see what happens if we add another large breakpoint, but we just change the background color to something else. Let's say maybe red. So instead of orange, it's going to be this sort of dark red color. So let's see which one is going to take precedence. If we go to the website and we go back to a desktop width, you can see that it is red. It's not orange, and the reason for that is the same thing. It's because of the cascade. So the red background color rule has overridden the orange background color rule. So this is one way that you can sort of control which styles take effect. And it's one reason why when you're using min with media queries, you want to have them in increasing levels of viewport width. So then what about max with media queries like we're using down in the sidebar here? Well, for these, the default styles are for the desktop widths, and then you're adding media queries for viewports that are up to a certain width. So in our case here, we're using the default text align of left for most of our styles. And then on top of that, if the viewport is 899 pixels and less for tablet, the text align is going to be centered. So let's just kind of review what the sidebar looks like in the website. So the sidebar is left aligned for desktop widths. And then once we hit that tablet breakpoint of 899 pixels and down, it's going to be centered. It's going to be centered all the way down. So let's say we wanted to add another media query for the sidebar rules for the mobile widths. So after the medium media query, we could say include u breakpoint down and then small, and that will hit at 699 pixels. And we'll say text align, just to keep it the same, right. So now, if we look at the website, once again, starting from desktop, we got our default left align. Then as a viewport decreases, once we hit the medium breakpoint at 899 pixels, it's going to be text align center. And if we keep decreasing the viewport, eventually at 699 pixels, it's going to be text align right. So you can see that this is kind of opposite of what we did with the min width media queries. When we're using the max width media queries, we have the default styles for desktop, then we keep tacking on gradually decreasing viewport width media queries. So it can be kind of hard to wrap your head around, the min width and max width media queries and breakpoints when you're first starting out. I know that I had a lot of trouble with this, so don't worry too much if it seems kind of confusing at the beginning. Just keep in mind that if you're noticing that for some reason your styles, when you're using media queries, they don't seem to be taking effect, or like the styles seem to be getting overridden, just go back into your styles and see if maybe the order of your media queries might be incorrect. And then you can sort of play around with the order and see what can fix the issue. Now, aside from the layout, making your typography responsive is another big part of responsive design. So I'm going to show you two different ways that you can do this. So in our VS Code, let's go into the globals typography.scss file and add some font styles for our h1 tag using media queries. So first up, we need to import that util module. So up at the top, we'll write @use ... util as u. Then we can set a font size for mobile for the H1 selector. So let me add that under the compound H1, H2, H3 selector. And again, our default styles are for mobile. And then we will add our larger viewport styles on top of that using media queries. So for default, let's say font size 28 pixels. And this is for mobile. And then we will add our breakpoint mixins. So include u.breakpoint. And I'll say this will be starting at medium tablet size. And we'll say font size 36 pixels. And then we'll add another breakpoint for our desktop styles. Include u breakpoint large. And I'll say font size 42 pixels. So we'll save that. Success, we don't have any errors. And let's check this out on the website. Okay, so looking at the website, we're going to inspect our H1 tag. So right now it says font size 28 pixels, which is what we had for mobile. And as I slide the inspector panel over, it's going to change to tablet. So the 43.75 EMs, it's going to change to 36 pixels, which we had. And then as we keep going larger, it's going to eventually change to the desktop breakpoint, 56.25 EMs, and font size is going to be 42 pixels. So 42 for desktop, 36 for tablet, and then 28 for mobile, which is what we have in our styles. So doing responsive typography this way with media queries was pretty standard for sizing your fonts, and I'm pretty sure a lot of people are still doing it this way now. It works, it's totally fine. which is why I wanted to show this to you. But there are a few ways that we can make our text responsive with just one line of code in our styles, so not needing these multiple breakpoints. So one way we can do this is by using a unit in CSS called VW, or viewport width. One viewport width unit is equal to 1% of a device's viewport. So on a mobile phone that's 375 pixels wide, one VW, or viewport width unit, is equal to 3.75 pixels. Then on a large screen that could be 1920 pixels wide, one VW would be 19.2 pixels. There is also a viewport height unit, VH, which does the same thing for the height of the viewport, but for our purposes here, we're going to be using viewport width. If we want the final font size to be around 28 pixels for a mobile device that's 375 pixels wide, we can divide, if I pull out my calculator here, we can divide 28 by 375 to see what percentage of 375 28 is. And we're getting 0.074666 repeating. And converting that to percentage, that's about 7.4 or 7.5% if we round up. So 7.5% converted to viewport width would be 7.5 viewport width units. So let's try that. 7.5 VW. And I'm just going to delete what we have here for the media queries. So now our H1 font size is set to 7.5 VW. So let's go back to our browser. And in the browser, I'm going to select the emulator thing. I'm going to select an iPhone size, which is 375 width. And if I inspect the H1 tag, 7.5 VW, and if we check out the computed tab, it says the font size is 28.1167 pixels, which is, again, about 28 pixels. So it's not exact, but it's pretty close. And let's also take a look at what this looks like for a tablet. So iPad, the font size is 60.75 pixels. And this is, again, still using the 7.5 VW because, I'll just illustrate this with a calculator, the viewport width of the iPad is 810. And if the font size is 7.5 VW, we'll multiply that viewport width by 0.075 to get 7.5% or 7.5 VW. So 60.75. If we check in the computed, it is 60.75 pixels. So I hope this helps illustrate how viewport width units are calculated to their final pixel value. Now you might notice that the font is getting kind of big. And if I turn off the emulator and just sort of keep sliding this back and over, the H1 tag text is going to keep getting bigger and bigger as a viewport increases, which is exactly what it's supposed to do. So if you imagine if you had a really, really large widescreen monitor and you're sort of full screening your browser, this H1 tag text is going to be really big, probably bigger than you would really want it to. So this is not completely ideal behavior because we don't want the font size to increase so much so quickly as a viewport width increases as well. So you can see on mobile, it's actually maybe a tad bit on the small side. As we increase, it just gets really big kind of quickly. Like this isn't even that wide and the text has gotten really big. So one way that we can actually limit the rate of growth when we're using viewport width units is to involve another number that's not dependent on viewport size in how the font size is calculated. So we can actually do this with the CSS calc function. What calc does is it lets you combine numbers of different units, which is in itself pretty cool. So if we go back into VS Code, in our styles for the H1 tag, let's replace the 7.5 VW with calc. So this will be the function. And in it, I'm going to say 16 pixels plus 2 VW. So what's happening here is that the 16 pixels is going to kind of ensure that the font size is always going to be at least 16 pixels because it's 16 pixels plus whatever 2 viewport width units ends up being. And I decrease the viewport width from 7.5 to 2 because we have the 16 pixels to sort of add font size to it. All right, so we'll save this and let's see how this looks in the website. So if we go back, let me turn the emulator on again and we'll select an iPhone size. So now the H1 tag has that calc 16 pixels plus 2 VW And then the computer tab is 23.5 pixels. So that's actually smaller than what we had before. And let's switch to the iPad. And again, the font size is smaller than what it was previously. It's 32.2 pixels. And if I turn the emulator off and go to like a desktop sort of width, it's going to be 36.15. So if we go back, let me just illustrate what we had before, just for comparison's sake. Font size was 7.5 VW. So this is overriding the calc thing that we had. So you can see how much bigger it is when we don't have the calc with the 16 pixel thing and when it's completely dependent on your viewport. So this is a little bit more, normal looking. The font's not growing quite as dramatically as it was before. So it's a little bit more desirable, right? Now, even though this does look a lot better than it did before, there's one problem that maybe you thought of, and that is that even though the growth isn't as dramatic as it was before, the text is still going to get bigger as the viewport increases. Like there's no limit to that. So if you imagine having this open on a really large screen, it's still going to be kind of big, maybe bigger than what we want. However, there is a solution to this, and that is another function. It's the CSS clamp function. So this clamp function will actually allow you to set a minimum and a maximum value to our preferred 16 pixels plus 2 VW font size. So let me show you what this looks like. So here, instead of the calc function, we're going to change this to clamp. And clamp will take 3 parameters. The first is the minimum number that we want it to allow. And we're going to say 28 pixels since we don't want it to be smaller than 28 pixels. The second parameter is what's called the preferred value. And this is where we'll have the 16 pixels plus 2 VW. And this is sort of our ideal font size. Then the last parameter is the maximum value allowed. So this is what we don't want the font size to go larger than. So let's say 40 pixels. And inside the clamp function, we don't have to use that calc function, and we can still mix units. So we're mixing pixels and VW here, which is allowed. Okay, so now this looks a little bit more complicated, but let's see how this looks in the website. All right, so starting for mobile, you can see our clamp functions working. So let's go on the computer tab again. And the H1 tag says 28 pixels font size, which is what we set as the minimum. If we keep going, you can see that it's not growing quite as much as it did before. The font size is increasing a bit to 29, about 30 or so as we get to tablet size. And then when we get to desktop size, it's 35. And it just keeps going. And let's dock to bottom to see if we can make it hit that maximum. So yeah, here it's at 40. And this is the maximum that we set it at in our styles. So overall, I would say that using clamp is a pretty good solution for responsive typography that doesn't require media queries, and you still have the control because you're allowed to set a minimum and maximum size of your font size. However, there might be some edge cases where you don't always want that kind of increase as the viewport increases. But if you do ever have a case like that where you need to have a little bit more control over the font size at different viewports, you can always fall back to media queries if you really have to. Again, using media queries to set your font size like I showed originally is a perfectly good solution. It's just nice to be able to write something using one line of code as opposed to multiple lines of code. All right, so I wanted to spend a little time talking about why you actually should not be using pixels in your CSS. I mentioned a while back that you shouldn't be using pixel units for sizes because it's not accessible. So let me show you what this means and why you really shouldn't use pixels at all, especially not for text sizes. So in our code, in our typography.scss file, we have our sizing for the H1 tag that uses the clamp function. And we're using pixels as well as the viewport width unit a little bit, but it's sort of mainly pixels here. So let me add a similar font size for the H2 tag. So I'm just going to copy what I have here, change the selector to H2. And I'm just going to sort of tweak the sizes because the H2 tag should be a bit smaller than the H1. So we'll say 22 pixels, take this down to 14, and then change this to 1.5 VW. So the rate of change is less as well. And then we'll max this out at 36 pixels and save. And then let's also add a font size for our paragraph tag. So font size, and I'm just going to say 16 pixels here. Okay, so we've added our font sizes for the H1, H2, and also the paragraph tag. Now, in our browser settings, I'm going to change the base font size. And you may or may not have used this setting before, but most browsers should have a setting where you can control our default font size. So by default, most browsers are going to have this at 16 pixels. I think Chrome should have pretty similar settings. I believe Safari has a setting that says never use font sizes smaller than, and then you can choose the font size, and it kind of does the same thing. So I think no matter what browser you use, you should be able to control the default font size. So let's change this from 16 to 36. And this is going to be more than double what 16 was. So now I think we have to manually reload the website just to get the settings to update. Okay, so now the text actually has not changed at all in the text size, if you notice. So let's go back to 16 really quick. So let me reload, and nothing's really changed. And this is because, if I change back to 36, the reason that it's not changing when you change your base font size is because pixels are an absolute unit in CSS. This means that their final size is not dependent on anything else. So the paragraph tag here is going to be 16 pixels no matter what you do in your browser settings. And yes, you can zoom in the browser to make the text bigger, and this works even if you have your font size set in pixels, as we do. However, I think it's really important that we as web developers allow the setting in our browser settings to actually do what it's supposed to do. And making your font sizes in an absolute unit like pixels takes away the control that the user should have over the page, since this setting does exist. So how do we fix this problem? Well, what you want to do is to use a relative unit that will scale up if the user increases their base font size in their browser settings. There are several relative units in CSS, meaning the units whose value is dependent on another factor. The viewport width unit that we were using is one example of a relative unit, as the value of one viewport width is dependent on the width of the device. However, we need a relative unit that is dependent on the base font size in the browser so that it'll change when your base font size is changed. And that unit, which is my most often used unit in CSS, is the rem or root EM unit. There's also an EM or M unit that you may have heard of, and I am going to talk about them in a little bit. So the root in the rem is from one rem being equal to the root of the website or the base font size set in your browser. So if the default base font size is set to 16, which is the default, then one rem will equal 16 pixels. And since we changed our base font size from 16 to 36, this will change the value of one rem from 16 pixels to 36 pixels. So let's change our style so that we're using rem units in all our font sizes, and you can see what the difference is going to be. So going back to our typography.scss file, in the H1 element selector, I'm going to duplicate this line using the VS Code shortcut Control-D. And I'm just going to comment out that first one. We're just going to keep it for reference. We're using this // to comment out the code. And commenting the code out, if you haven't used this before, just means that it's going to be ignored by the software. So we can type whatever we want here. VS Code is going to ignore whatever's on that line because we've commented it out with those two //. So this is a handy way to keep helpful notes or, temporarily save code that you might want to look at later on. So now in the second line here, we're going to convert from pixels to rems. And let me pull up my calculator per the usual. And I'm going to assume that I want one rem to be 16 pixels. So to get from pixels to rems, I'm going to divide all the pixel values by 16. So 28 pixels divided by 16 is going to be 1.75 rems. 16 pixels is going to be equal to 1 rem. And then 40 pixels divided by 16 is 2.5 rems. Okay, and then we'll save that. And one thing to note is that the viewport width unit that we are using in our preferred font size in the clamp function is not dependent on base font size, even though it is considered a relative unit. So one viewport width unit is not going to change when the base font size changes, but since we're using 2 VW and it's added to the 1 rem, the final calculated value of that middle parameter is still going to change when the base font size is changed. So that's just one thing to keep in mind. Try to only use viewport width units for font sizing if it's added to a number that is using a unit like rems that's dependent on base font size. So back in our code, in the H2 element selector, we'll do the same thing where we'll duplicate the line, comment out the first one, and then we'll convert from pixels to rems. So 22 divided by 16 is 1.375 rems. 14 divided by 16 is 0.875 rems. And then 36 divided by 16 is 2.25 rems. And then for the paragraph, font size is 16, and we know 16 divided by 16 is 1 rem. So we'll do that, and then we will save. Let's go back to our browser, and let's go back to our 16 pixel base font size, and then reload. So in the browser, let's inspect that H1 tag. We want to make sure that the font size has been updated to use rems, which does seem like that is indeed the case. And the computed font size is 28 pixels. So now that we know what it looks like when the base font size is 16, let's go back into our settings and change it to 36 again. Okay, so we reload the website manually, and you'll notice that the website does look different. So the text has gotten bigger. It looks like we've zoomed in, even though we haven't changed the zoom at all. And you also might notice that the layout is sort of staying at this one column layout. So having the text increase when you change the base font size to something bigger is an ideal user experience because you're letting the user have the control over how big or small the font is when they change the default font size in their browser. So I hope this helps illustrate why using relative units like rems are better for accessibility. Now, what about the EM or the M unit? I know that some people like using M units for font size, and I think that's okay, but M units do have a quirk that can sometimes cause unintended behavior. And this is because while rem units are based on the base font size in our browser settings, M units, when they're used for font size, are based on the font size of the parent element on the page. So let me show you what I mean in the code. So first off, let's change this back to 16 in our base font size. And in our code, I'm going to change the paragraph font size from 1 rem to 1 M or EM. I'm not really sure if it's preferred to say M or EM units. I sort of use both. So now that we've changed the paragraph to 1 EM, let's go back to our website and I'm going to reload. And when I select and when I inspect a paragraph tag, font size is set to 1 EM, which is good. And then in the computed tab, it says font size is 16 pixels, which is what we want because we have our base font size set at 16. And the reason that this is working off the base font size is because the paragraph doesn't have any parent elements that have a font size explicitly set. So if we look here in our HTML, the parent elements of the paragraph tag are the main tag, and it doesn't have a font size set. And then it has a grid div. Again, this doesn't have a font size set. And then we go up to the body, no font size, and then up in the HTML, which is font size 100%, which will read from your base font size settings in the browser. So this will be equal to 16. So let's change this up a little bit. So going into our code in the grid.scss file, I'm going to add a font size to the grid class selector. So let's say font size, and let's set it to 2 rems. So this is going to be equal to 2 times 16 pixels because rems are dependent on the base font size in the browser. 1 rem is going to equal 16 pixels right now. So 16 times 2 is going to be 32 pixels. So we'll save that. And now, if we go back to the website, the paragraph text size got really big. So this is happening because the 1EM in our paragraph styles, if we inspect it again, it's 1EM, it is now basing itself off the 2 rems or 32 pixel font size in the grid div, which is one of the parents of the paragraph tag. So the font size is 2 rems, which equals 32. And then the paragraph tag, which is 1EM, 1EM is going to now equal 32 pixels coming from this grid class element. So this is why if we go to the computed tab on the paragraph tag, the final font size is 32 pixels. Again, this is because of the grid element using a font size of 32 pixels. So 32 times 1EM is going to be 32. And this can sometimes be desirable if you do want, say, your paragraph tag to be dependent on a parent element. However, another weird thing is that this effect is actually multiplied if multiple ancestor elements use the EM unit. So let's go into our code, and I'm going to change the grid class font size to 2 EM units instead of 2 rems. And then, after I save that, I'm going to go into my boilerplate.scss file, and I'm going to add font size to the body tag. So let's say font size 1.5 EMs. So now we're using EMs in the body and in the grid class element and in our paragraph tag. So they're all using EM units. So let's see what happens now. So going back to the website. Okay, so now the font size is really big. So we check out the computed tab. Font size is now not 32 pixels like it was before, but it's now 48 pixels. So this is because we have this sort of nested multiplier effect. So I'm just going to pull out the calculator just to sort of illustrate this a little bit better. But why this is happening is, one, the root font size set in the browser is 16 pixels from our settings. So 16. And then the font size of the body tag is 1.5 EMs, so 16 times 1.5 is 24. And I think we should be able to see that if we select the body tag in our inspector, and in the computed tab, font size is, yes, 24. Then if we go down to the grid class element, the font size is 2 EMs, and that's going to be based on the 24 pixels from the body. So 24 times times 2 EMs. So that's going to be 48. And if we go to the computer tab, the font size is indeed 48 pixels. And then on top of that, the poor paragraph tag, which has a font size of 1 EM, is going to be equal to whatever the parent is. So that's going to be, again, 48. And if we go to the computer tab, it is 48 pixels. So obviously this is kind of an edge case. You're not always necessarily going to run into, multiple ancestor elements that have all their font sizes set in EMs. But in my opinion, I just find it easier to use rem units because it's always going to be based on your browser-based font size. But again, it's perfectly fine to use EM units if that's your preference. Just make sure that you're aware of this sort of nesting multiplier effect issue if you do use them. So I'm just going to go back and let's just reset all of our styles back to default. I'm going to remove the font sizes that I added. And we'll change this back to 1 rem. All right, so we've established that it's best to use a relative font size unit like rem or EMs. But as you saw, when converting from pixels to rems, I kept having to pull out my calculator, and as you might imagine, that gets old pretty fast. Just for context, there is a workaround for that makes the math easier so you don't have to divide by 16. I'm going to mention that just because I think some people do still use it. So what it involves is setting the font size in your HTML selector to 62.5%. I'm just going to comment out the 100% for now. And what this does is usually when we have font size set to 100%, That's going to base itself off of the base font size in your browser settings. When you set it to 62.5%, what it's doing is it's going to take your default font size, which is by default 16, and it's going to multiply that by 0.625 to get 62.5%, which will then make one rem equal to 10 pixels instead of 16. And this is all purely just to make doing the math a little bit easier. So instead of having to divide by 16 to get from pixels to rems, you can divide by 10, which is a lot easier to do with mental math. So for example, if we have our font size set to 62.5%, let's say we want to set something to 30 pixels. Instead of dividing 30 by 16, we can simply divide 30 by 10 to get 3 rems. Now, I don't see any actual issues with this workaround, but personally, I just prefer to keep things set at the default 16 pixel size. This workaround was invented to make the mental math easier since Sass at that point didn't really exist. However, now that we do have Sass, I feel like a better solution is to create a Sass function to do all the conversions for us. So let me move this back to 100%. And let me show you how we can use Sass functions to accomplish this conversion. So I'm going to create a new Sass partial in our SCSS util folder, and I'm going to call it _functions.scss. And since we've created a new Sass partial, I need to update the index SCSS file in util. So forward functions. And then I'll just close that for now. So what do we want to accomplish with our function? Well, we want to create a function that will divide a given pixel amount by 16 and then return the number of rems that is equal to. So basically in every case where we've set a font size or some other size, instead of using pixels, we can use this function and then use the pixel in it probably as a parameter. And you'll see more about what this is going to look like as we create this. So in our functions Sass file, we want to create our function. So you can do that by using the @rule, @function, and then write the name of the function. I'm going to name this rem. And we're creating a function. And this rem function is going to take one parameter. I'm going to call it pixel. So $, pixel, because it has to start with a $, for Sass variables. Then in this function, we want to divide pixel by 16. So just to remember that, divide pixel by 16 to return rems. And I'm just leaving this as a temporary note to myself. I find it helpful when I'm creating functions to remember everything I want to do with it. Now, one thing to note is that in the old version of Sass, we used to be able to use a / to divide pixels by 16. So it could be something like pixel divided by 16, yada, yada. However, since we're now using / when we're loading our Sass modules, we can't use a / for division anymore since it's not going to work. Instead, Sass has a built-in module that lets you do some different math functions, and we're going to be using that. So let's do some research. I'm going to show you the Sass website with the documentation, and we'll use that to figure out what we need to write. So since you might be doing this if you're using Sass in your own life, I'm going to search for Sass math. And here we have the Sass website, sass-lang.com. And on the website, it is giving us Sass math, and it's part of the built-in modules section. So let's check out the overview just so we can see, how to use these built-in modules. Let me actually zoom out a little bit. Okay, so Sass provides many built-in modules which contain useful functions like what we're going to use. These modules can be loaded with the @use rule like any user-defined style sheet. So this is kind of like in the same way we've imported other Sass partials using the @use rule. We can do this to load this built-in math function, to load this built-in math module. And then all built-in module URLs begin with Sass : to indicate that they're part of Sass itself. So it's built in. We don't need to worry about the file path or anything like that. And here's an example of this. So @use, and then in quotes, Sass:color. And then it tells you how to use the module. So we can see in the border property here, it's using in the color value this color.scale function. And the color is the namespace, and that comes automatically from the name of the module, which is Sass color. So color.scale, color is a namespace, scale is the name of the function. And it tells us the different built-in modules that we have with Sass. So Sass math provides functions that operate on numbers. Then they have other ones here, Sass string, Sass color, list, map, which we used in our breakpoints, selector, and meta. So I don't use all of these. I generally just stick to the Sass map for my breakpoints mixin, and then I'm using Sass math for this function to convert from pixels to rems. So let's check out Sass math. And actually, let's import it since we have the logic here. So @use, and it's going to be in quotes, Sass:\math. So we're going to do this at the top, @use, and then in quotes, and I'm using single quotes because of my prettier settings. So Sass:\math. And I think I'm not going to use a custom namespace like what we did with the breakpoints mixin. So we'll just remember to use math as a namespace name when we use the function. Okay, so let's check out Sass math and see how we're supposed to do division here. So they're telling you all the different functions that you can use with math. And if you ever have to do math in your Sass style, you can just look over the documentation site. I feel like Sass has a pretty good website, and I've found the documentation to be pretty helpful. So there's a math max, a math min, round, so all kinds of different things. So distance, exponential, trigonometric. Okay, so in other functions we have here, math.div returns the result of dividing number 1 by number 2, which looks like what we want. So yeah, so what we want to do is math.div, and we want to divide the pixel parameter by 16 to go from pixels to rems. So let's copy this. And we're going to say, just paste that in here. And we want to use pixel as a first parameter, and then 16. Okay, so we have what we need here. This isn't quite correct syntax yet. So we want to return the result of this. So let's go back into the doc site and check out the @rules, because we're going to have to use one of these here. Okay, so here in the @function @rule, so it'll give us some extra info about that. And we can kind of see the right way to write a function. Okay, so we can see here @function pal, so it created the function using that @function rule. There's a for loop using the @for, and then here the @return result. So this is probably what we want to use, @return. There we go. Okay, so now it looks like it is valid. So we want to return, so let's think about this. I don't really want the pixel unit in the numbers, so let's just assume that when we use the rem function, we're going to write something like, this is just sort of pseudocode here, font size. So instead of 30 pixels, we're going to write rem 30, and then this rem 30 is going to take the 30 number as the pixel parameter, and then it's going to return the number of rems. And then I want to tack on the name of the unit, which is rem. So I should be able to, at the end of this, add a plus rem. Okay, so let's just try this out and see what happens. All right, so if we go back to typography, in the H1 tag selector, we're going to start converting our original pixel sizes into rems using the function. So I'm actually going to delete that second line since we don't need that anymore. Keep the first line, and we're going to use the function now. And Yeah, so we already are importing the utils because we used the breakpoint mixin earlier. So we can just keep that there. So I'm going to replace the 28 pixels with the u.rem. And in here, we'll say 28. Then we'll do the same thing, u.rem 16. And then 40 pixels will be u.rem 40. Let's just save and make sure we don't have any errors. Okay, looks like it's success. So we'll do the same thing for the H2 element. I'm going to delete that second line where I manually converted, and then uncomment the first line. And then instead of 22 pixels, u.rem 22. Instead of 14, it'll be u.rem 14. And then instead of 36, u.rem 36. And we'll do the same thing for paragraph. So that was supposed to be 16 pixels, so we'll say u.rem 16. And we'll save. Okay, so let's take a look at the website and just make sure everything is working. So back to the website, go down to mobile size, and we'll inspect the H1 tag. So it does look like things are working. It's converted from 28 pixels to 1.75 rems. And yeah, so that looks pretty good. And as we increase the viewport, it is getting bigger. And let's check the paragraph tag. 1 rem, which is correct. And then 16 pixels. And then this is the H2 tag. And it's using the clamp function, rems, and that looks good. So it seems like our function is working correctly, which is great. However, what if we made some kind of typo where there's an error in the function? So let's go back to our code. And let's say in our paragraph tag, instead of remembering that I just need to write the number without the pixel unit, what happens if I forget and I type in 16 pixels as a parameter? If I save, looks like everything is working. It says success. And let's check the website. It looks normal. Uh-oh, if we look on the paragraph tag, now the font size, it says 1 pixel rem, and it's crossed out because this is invalid, but it is still 16 pixels because this is just the default size. So this is obviously not good, and the reason that happened is because the parameter is 16 pixels, which is incorrect. And if we look back at our function, since Sass does recognize that the pixel unit is still a number, it'll divide it by 16, and then it's going to tack on the rem at the end to add the unit. So this is why the math ended up with 1, because it was supposed to be 1 rem, but it still had that px pixel from the parameter, and then it just added the rem, on top of that from our function. So this is not great for a couple reasons. One is that when we compiled our Sass, it said success. It didn't catch any errors. And the only way we would have found out would be if we actually looked at the website, and if something was off, we would have to look in the inspector and see what's going on here. And then we would see this 1 pixel rem thing going on. So this isn't really desirable because we would like to maybe check and make sure that the parameter format is correct and that we are not using any units at all in our function. So what I want to do is throw an error when we compile our Sass if the parameter in this rem function is using the pixel unit by mistake. And this sounds a lot like actual programming, and it kind of is. Sass comes with a lot of functionality that you might not initially associate with just writing styles like CSS. Now, some of these things you would have to import the built-in Sass module like we did with the Sass math module. And there are some other things that just come out of the box with Sass and you don't have to explicitly import the module. And this is things like if, else, conditions, things like that. So let's go to our function Sass file again, and let's figure out what we want to do. So ideally, we would like to, I'll just make a note here in a comment, throw an error if the parameter has a unit. So this could be any unit, it could be pixel, it could be EMs, rems. We really just want just that number to be there. So let's look at the Sass website again and see what our options are. So in the Sass website, if we go up to the top, there is a search function, and I'm going to write in unit, and see what comes out. So color units, that's not really what we're looking for. Okay, so this looks pretty promising numbers. Sass has powerful support for manipulating units. Unitless numbers can be used with numbers of any unit. This is interesting. Sass math returns whether a number has no units. And this sounds kind of like what we want. We want to check to see if the parameter has a unit or not. So let's check this out. So here is a function that looks like it'll do what we want it to. So math is unitless. You pass in the number, and then it's going to return a Boolean, which means a true or false, on whether that has units or not. So let's look in our code and sort of try to figure out what this is going to look like. So we want to check if the pixel parameter has a unit or not. So if pixel has a unit, throw an error. Then we'll say otherwise, aka else. If it does not have a unit, then there shouldn't be an error, and we will divide pixel by 16 to return rems. Okay, so now we've sort of mapped out what we want this function to do. Let's go back to the website to see how to write the if and else conditionals. Let's do a search for if. Okay, so at if and at else. So this will kind of tell us the correct syntax to write this in Sass. So at if, and then we'll use curly brackets. So that looks pretty good. And here's sort of what we want. It has both if and else. So we just use curly brackets to write the code inside them. Okay, so this is good. So if pixel has a unit, throw an error. So at if, and then we want to use the, let me just write some curly brackets first. So at if pixel has a unit, throw an error. And then we want to write checking if pixel has a unit. So once again, let me just go back to where we were with the unit thing. Actually, let me just search again for unitless. Here we go. Okay, so math dot is unitless. So if math dot is unitless, and then in parentheses, it'll be what it's checking. And we want to check pixel. So if math is unitless, pixel, then we want to throw an error. And again, we're going to do a search for error. All right, so at error, when writing mixins and functions that take arguments, you usually want to ensure the arguments have the types and formats your API expects. If they aren't, the user needs to be notified and your mixin function needs to stop running. This is exactly what we're doing. So you just use the at error rule and then put your error message in quotes. Error. And then we'll say something like error, or we'll just say don't. And since I'm using a quote in here, we need to escape it with a backslash. Don't. And then this will be the end quote. Don't use units when using the rem function. Only numbers. And we'll save that. Okay, so that's our error message. Then we will write our else statement. So else, if the number does not have a unit, which is correct, then we want to run our function to do the math and return the correct rems. Okay, so let's save that. Oh, and it looks like something might be happening. There's an error message. So let's just check out that. Okay, so it looks like our error message does seem to be working. And this is telling us that the issue here is line 12 of typography, SCSS, line 12, and I believe the 20 is like the column or the character number. So typography, line 12. Oh, hold on. Looks like that should not be hitting an error. So something's wrong in our function. Okay, so we actually got this kind of backwards. So this is saying if math dot is unitless, so if it is unitless, we've made it throw the error, which is the opposite of what we want. So I'm going to move this error message down to the else statement and then move that back up here. And we'll save. Okay, so now it should run our function if it is unitless, which is correct. And then otherwise, if it is not unitless, it has a unit, then we will throw our error. So let's check this again. Okay, so now it's saying this error happened in typography line 21, font size UREM 16 pixels. So that seems like what we want to happen. So line 21 is the paragraph selector, and it indeed is using that pixel unit, which we don't want. So let's delete that and save. And now it says success. Awesome. So let's go back to our website and just make sure that the paragraph is using the correct unit and it doesn't have that weird pixel rem thing going on. So yeah, this looks good. So here's the paragraph tag. Font size is 1 rem. All right, so this looks like everything's working the way that we want it to. H1 tag is good. So just to note, there is a lot of Sass functionality that I personally don't really use, and I'm not going to be covering it in this course because it can get kind of advanced. People use Sass for a lot of kind of advanced things like generating class names, in a loop, things like that. I'm showing you all what I actually use myself, but you can, of course, explore more of what Sass does offer outside of this course. I recommend CSS Tricks and Andy Bell for places that you can go to find some more advanced Sass topics and tutorials. So now that our rem function is working, let's just go back through our styles, and we want to replace any instance of pixels with that urem function. So let's check back in typography. We're using the urem for everything here. Looks pretty good. And let's check also in grid. So yeah, we're using the 40 pixel for the gap. So we're already importing the util module, which is good. So we can replace this with u.rem 40. And if we keep going, this is the same thing. So u.rem 40. Okay, looks pretty good. Another thing you can do if you're searching through your style files, which you probably will be doing pretty often, in VS Code, you can hover over the folder name. If you right click, you can say find in folder. You can also use this hotkey here. And then I'm going to search for pixel. And then it's going to tell you all the places where it exists. So this will tell me where I need to change this to use that rem function. So in layout, I forgot this part. So urem, again, it's 40. So now you can see it's actually updating. This is fine. It's in a comment, so it doesn't really matter. So that seems to be all the instances that I need to worry about, which is good. Okay, so this is pretty much everything we need in order to convert from pixels to rems. So basically, when we're building this website, anytime we want to set a font size or some kind of space that uses, a number, instead of using pixels, we can just use this function to convert from pixels to rems. Now, I do acknowledge that it does seem like there's a lot of steps in order to, size up our typography, convert things from pixels to rems, just to make sure that everything is both accessible and it scales up nicely. I totally understand why some people just use pixels in their styles even today because it's easier for the developer. However, we really need to keep the end user in mind when we're building websites, and using pixels is not accessible for users who are changing their base font size in the browser. So even though there is this extra step with a rem function and everything, I personally think that it's worth it in the end, because once you've set it up, you can just kind of reuse it and you don't have to keep reinventing the wheel every time. And you can use this rem function in all your projects going forward. And actually, another thing we can do to make our styles a little bit better is, if you remember, in our breakpoint Sass file, we have everything listed in EMs, but we did manually convert from pixels to EMs. So what we could do is create another function that's very similar to the rem function to convert from pixels to EMs. So we can do that here. I'm just going to delete the comments since we don't need them anymore. And I'm going to copy our rem function and just make a new function under it called EM. So it's going to be pretty similar. And then I want to update any instances of rem to em. And this is basically going to do the same math, but it's just going to tack on the em unit instead of the rem unit. So now with our em function, let's go back to breakpoints. And we need to import the util, or we need to import the functions. And we need to import the... This is a little kind of weird because we're already in the util folder, so you can't really import util into util. It's going to cause an error. We can try it, so just so you can see what this looks like. So use, and we're already in the util folder, util as u. And this is causing an error, as we predicted. Can't find the style sheet, so what happens if we just do this? Or this. Yeah, so this is not going to work. Module loop, this module is already being loaded. So what we need to do is we only want to import the functions SCSS file. So what I'm going to do is say use, and we're in the breakpoint Sass file, so it's in the same level. So we can just say use functions, and I'm going to give it a namespace as f. Save that. Okay, so there's no error, which is good. So now for medium, instead of 43.75 EMs, we can say we can say f dot em 700. Save and just make sure that works okay. And I'm actually also going to do one other check to make sure that this is getting output correctly in our final CSS file. So if I go into the dist folder, I'm going to open up the style.css file, and I'm going to save to run prettier. And I'm going to look for a media query to make sure that the medium is indeed, loading the correct EM value. So maybe I'll just do a Control F to search for media. There we go. So min width 56.25. That seems correct, but it should be medium. And medium should be 56.25 is large. So medium is going to be the 43.875 type number. So let's keep searching. Here we go, 43.75. So that seems correct. So that tells me that this function is indeed working correctly. So I can now, with reasonable confidence, update all of these. So FEM 900, FEM 1440. Then we can do the same thing here. So FEM, and if I want to save some time, I can copy this blank function, paste it in here, paste it in there, and then just type in the pixel number that I have saved in my comment, because past me remembered to do that. 899.98, 1430, oops, 1439.98. Sweet. So let's check our style.css file again. So I'm going to save to run prettier and do a search for media. And let me just sort of move this down. All right, 56.25 EMs. Yep, looks like our media queries are pretty good. Yeah, and these are the max width ones, which is why the decimal point is longer. Okay, and the final check is, of course, to load the website and make sure everything seems to be working with our media queries. Yep, things look pretty good. If I check out the rules from main, yeah, min width 43.75 EMs in our media query. So yeah, awesome. All right, so now that we have our font size and other properties set to use rems, I'm going to show you why I use EM units in my media query breakpoints instead of pixels. And I'm only mentioning this just because it seems like pixels seem to be the most often used unit in media queries, And this includes, really big websites, even some front-end frameworks. But in my personal research, I've found that EM units are actually better, and you shouldn't use pixels anywhere, and also not in media queries. So we're going to go back into our breakpoints.scss file. And what I'm going to do to demonstrate this is go back and use pixel units for our breakpoint sizes. So just to make sure we keep this, I'm going to press Control D to duplicate. Then I'm going to comment out this because we are going to go back to using our EM function. And I'll duplicate the breakpoints down as well and comment that out as well. So Control K, Control C to comment. So now I'm going to go back to pixels for these 700 pixels, 900 pixels, 1440 pixels. And then the same thing here, 699.98. Oops. Okay, so it looks good. All right, so now we're going to save. And let's go back to our website. Okay, so things look pretty much the same. We can see that, yes, our media queries now are back to using pixel units. And, when we slide things back over, things look pretty much the same, which is correct. So the problem happens when you start changing the browser-based font size. And let me show you that. So in our settings, we're going to change, instead of the default 16 pixels, I'm going to double it. So it's going to now be 32 pixels for the default font size. So now let's go back to the website and we're going to manually reload to make sure the setting changes worked. Okay, so now you can see things look different. So what's happening is because we increased the browser-based font size, all the text has increased in size, which is correct. This is what we want because the text size is using rems. However, this isn't a really great user experience having the content in 2 columns, but because the text is bigger, things are really narrow. It's kind of cramped. This would not be the best way to sort of navigate and try to read a website. And the reason this is happening is because our media queries are set in pixels. And since pixels are an absolute unit, they're not affected when you change the browser-based font size. And therefore, the breakpoints are still going to be at 900 pixels for our layout. So you can see it's going from 1 column to 2 columns at the same viewport width at 900. But since the text is bigger, we actually want our breakpoints to scale up. So, since the text is 2 times the size, when we change from 16 pixels to 32 pixels for our base font size, we also actually want the breakpoints to increase as well. So 900 times 2 would be 1800 pixels. And we really wouldn't want the design to go from 1 column to 2 columns until we go much wider at 1800 pixels instead of 900 like this. So we can see this is kind of not ideal. So let's go back into our breakpoints, and I'm going to go back to our old, using EM units. So I'm going to uncomment that, delete that duplicate one, and then do the same thing here. So uncomment, Control K, Control U, and delete the pixel version. So now let's save. And again, let's go back to our website. And when we hit reload, just to make sure things went through, we can see that instead of being stuck at that 2 columns with super narrow content, we are back to 1 column. So you can see we're just going narrower and then wider. And let's see if I can sort of force this to become even more wide to try to hit that breakpoint where it goes to 2 columns. Let's try dock to bottom, and it's still 1 column. So I think I can do, if I select the laptop, then I can actually put in the 1800. Let's just go 1900 just to make sure, extra sure that it hits the breakpoint. There we go. So now this is a little bit zoomed in because 1900 pixels is wider than what we can show right now. So I'm going to zoom out just for illustration purposes. So you can see here is the screen, and it is in 2 columns, and looks like I did make a mistake here. So I need to make this 1000 pixels into rems. So let's just go back and fix that. So this is in the grid parent element. So it's that width thing. So I need to say, instead of 1000 pixels, u rem 1000. There we go. Let's just do a quick scroll down here. All right. So we save that. And then now going back to our website. So we have the 1900 viewport width set. So it is still a little bit bigger than our screen, but you can see now that the content looks a lot better. You know, it feels like you can sort of breathe a bit easier with the content. And it's not super narrow like we had before. So let me just change everything back to what we had before with 16. And then our normal zoom. So I hope that sort of explains why it's better to use EM units in your media queries. You can use rem units. They're also a relative unit, but at least at the time of this recording, there is a bug in Safari that if you zoom in on your browser, it will make the breakpoint hit at a different viewport. It's more of a minor problem than the sort of cramped content that we were seeing when we used pixels. But for now, I would just stick with EM units when you're using media queries. All right, so now we have all the building blocks that we need in order to build a responsive website. We have our media query breakpoints set up with the Sass maps and our mixins. We have the font sizes scaling up using the CSS clamp function, and we're keeping things accessible by using rem and EM functions to convert from pixels, so we're using those relative units. So the last part of the section, we're going to be building out this demo website a little bit more, and also delving a bit deeper into BEM, the block-element-modifier approach. Now, so far, we've used BEM to create the classes for grid, which is the block, and then the grid __ main, and the grid __ sidebar, which are elements of that grid block. So now I'm going to add some more elements to the sidebar. Specifically, we're going to add some sidebar widgets, which are going to be blocks of content within the sidebar itself. So let's start by adding some markup into our index.html file. So here's our index.html file. And if we go down to, here we go, grid sidebar. So in the grid sidebar aside tag, I'm going to create a new div. So using emmet, we'll say dot for the class. This is going to be called grid __ widget. And I press enter and it's generated the HTML for me. So now I'm going to select the H2 tag and the paragraph tag and press Alt and up arrow, and it'll sort of move it in the HTML markup. Okay, so now we've moved the sidebar content into a new div called grid widget. And let's make a couple more widgets. So I'm going to select the grid widget and I'll press Control D a couple times. So now we have 3 widgets. And let's just make the text look a little bit different in the other widgets. So the second widget, I'm just going to say something like, check out this cool thing, exclamation point. And I think I'm also going to delete some of the text from this one to make the length a little bit different. So we'll do just something like this. And then in the third widget, I'll kind of do the same thing. More cool stuff is right here. So we're going to make the title a little bit longer in this one, maybe 2. And maybe I'll make this text longer as well. So we'll use the emmet shortcut lorem 18. So I think that should be 18 words. So let me Alt Z to word wrap. Yeah, it makes the word wrap kind of weird. Okay, so now we have our 3 widgets. They have slightly different text in them. And this is something that I do on purpose because when you're working from a design, a lot of times the designer is just going to put in placeholder copy. That's kind of a word for text, copy, since the final copy is usually not going to be ready until later on and you're about to launch a website. So one thing that I try to do in the development process is to sort of stress test the design. So I try to see what happens if there's different lengths of text, or, you can do the same thing with images and just make sure that you sort of take into account any sort of possibility that the website might need to have later on when it's been launched and it's kind of existing in the real world. So one thing to test is different lengths of text and just see if, things look different or maybe the design needs to be tweaked a little bit. So now let's check out the website. And we can see that we have the different widgets in the sidebar. And we have different lengths of text, which is good. So we have one line in the title for the first widget, and then the second and third widget have 3 lines. Okay, so what I want to do now is add some themes, I guess you could say, to the sidebar widgets. And each theme of the widget is going to have a different background color. So in our code, let's go to I'm just going to close this. Go to the grid.scss file, and I'm going to create some new elements in the grid block. So right now we just have main and sidebar as elements. I'm going to add some new ones. So after the sidebar element, I'm going to say ampersand __ widget. And then what I'm going to do is also move that background property. And what I'm also going to do is move this background color from sidebar into the widget itself. And we're going to kind of build off of this. Okay, so now let's go back to our website. We can see now each individual widget has that magenta background, and now they're kind of differentiated. And one kind of weird thing about CSS that I want to point out to you is related to this space between the widgets. We didn't add any margin or padding or other properties to the widgets. There's just this space between them. So, where is this space coming from? Well, it's coming from some default browser styles that get applied to some HTML elements. One example is that a paragraph, and I think we should be able to see this if we inspect this, a paragraph tag is going to automatically have some spacing built in, even if you don't explicitly give it spacing or margin in your styles. And what we did in our styles is we actually canceled out the margin top property that by default will come with a paragraph tag. So if I uncheck this in the tab and I hover over the paragraph tag up here, you can see that there's a top and a bottom margin. And the bottom margin is why there's that weird space there. And let's take a little bit closer look at this as well. So I'm just going to go back to a 1-column layout, select that P tag, and if we go to the Layout tab in our inspector and open the box model panel, so we can see that the paragraph has a top margin and a bottom margin of 16 pixels. And this 16 pixels is from Firefox, a browser that I'm using. And in this case, it's adding a margin that's equal to the font size. So the font size in the paragraph tag is 16 pixels. And so Firefox will automatically add a top margin and a bottom margin of 16 pixels as well. And other browsers are going to do the exact same thing. And if this seems weird and confusing to you, I'm right there with you. This is just one of those weird quirks. I think these automatic margins are kind of a holdover from back before CSS really existed and web pages were just kind of written with straight up HTML tags. So they looked more like Word documents than anything else because there weren't any styles applied to them. So if you think about websites from that point in time, it does kind of make sense that you might want some default styles just to make the web page more readable since you're just using tags and not CSS. Unfortunately, even though we can control spacing and margin and padding, now with CSS, we still have this feature which can kind of lead to some unexpected behavior. Unfortunately, even though we can now control spacing with CSS and the margin and padding properties, we still have this feature that can cause some unexpected behavior. So it's just good to know, which is why I mentioned it here. If you're wondering why some elements have spacing, even if you didn't explicitly give them spacing in your styles. And along with this, there is another very strange quirk that comes with these automatic margins, and that's what's called margin collapse. And we can actually see this happening on this website right now. So another element that has default margins is the headline tag, so the H2 tag and the other headline tags. So let's go to this headline tag. If we just make sure we have it selected and we have our layout tab open with a box model showing, you can see that it has this bottom margin of 20.7777 pixels. This is calculated again by the browser. It's calculated by multiplying the font size of the H2 tag by 0.83 to hit this margin size. This exact multiplier might differ slightly across browsers, but they're more or less going to be around the same, and they're achieving the same thing. They're just adding some spacing to the H2 tag. And again, because I canceled out the margin top, if I uncheck this rule, we can see some additional spacing has now been added. And we have both a top and bottom margin of 20.7777 pixels. And you might be wondering if the H2 tag has this margin top. Why is the margin sort of outside the purple box? And we can see this is happening with all the H2 tags. And this is why there's that space between the widgets. And also, I've canceled out all the margin top properties that we added. And if we look at the first widget, you can see that the H2 tag has that bottom margin of 20.7777 pixels. And the paragraph also has a top margin of 16 pixels. But if you hover over both of them, it looks like the margins are kind of running into each other. And so the final space between the H2 tag and the paragraph tag is actually the 20.7777 pixels. You can see the top margin from the paragraph is kind of sort of included in the bottom margin from the H2 tag. So these weird things are happening because of this margin collapse thing. You have two elements and you have, a bottom margin and then a top margin between them. The browser is only going to give a space that will match the biggest margin between those two elements. And the other margin sort of collapses or just gets included in that. So you might be wondering how to, fix these weird quirks if you do encounter them. One way that you can actually get rid of them is if you apply some CSS style rules to the parent, which will create what MDN calls a block formatting context. And creating a new block formatting context will get rid of this margin collapse effect. And you might actually be doing some of these things on your own without realizing it. So let's say if we add a border to the grid widget, which is the parent of the H2 in the paragraph tag. Let me show you. So border 1 pixel solid green. Oh, so you sort of see this happening. Let's just make it yellow to stand out a bit more. So when we added the border, suddenly the top margin is included in that purple background of the widget. And if we uncheck it, you can see that again, the margins are kind of collapsing into each other. So this is a very strange part of web development. I personally don't understand why this still happens, but it's there. Since it still exists, I need to explain this to you just in case you do encounter this weirdness in your own work. So another way we can make a new block formatting context happen is if we say padding 0 pixels, 1 pixel. So if we add even 1 pixel of padding, it will create a new block formatting context, and then the margins will not collapse into each other anymore. So these are properties that, you will probably be adding a lot of times just not on purpose to get rid of the margin collapsing thing, but it just happens. And so, yeah, it's kind of weird. If you look up at MDN, there are a lot more conditions that can create a new block formatting context. So let me just show you this really quick. So I have the link copied already. So this is how you can create a new block formatting context. So absolutely positioned, table cells, all these different properties. I don't fully understand all this myself, but the way it kind of plays out, at least when I'm doing work, is that if you start adding styles to the parent, it's going to get rid of the old Word doc way of displaying the elements. And so it's going to get rid of the margin collapse and weird spacing. And instead, it'll start behaving according to the actual CSS rules that you have applied to it. This is a weird quirk. I really don't understand why it's still happening, but it is. So this is why I mentioned this. So anyway, that was a very long explanation, but let's go back into our styles. And what I'm going to do is add some padding to our grid widget elements. So we'll say padding, and I'm going to say maybe 16 pixels of padding. So we'll use our rem function. urem16. And this is going to make 16 pixels of padding all the way around all of the widgets. So let's see what that looks like. So now you can see that the spacing is around each widget. And if we hover over it, you can see that there is 16 pixels of padding. So now these look a little bit more readable. It's not just going all the way to the edge. Okay, so now that we have our base widget styles in place, let's start making the different widget themes with the different background colors. So what I want to do is I want to create a BEM modifier, so BEM, block element modifier. I want to create a modifier that will add a background color of green to the widget. So in our code, let's create our modifier selector. So this is something that we're going to add to the widget element selector. So inside the widget rules, I'm going to add an ampersand and 2 hyphens or dashes, and then the word green. And then we'll add a background color, and we'll say green, and we'll sort of make this maybe just a little bit darker. Actually, I think it's okay. Okay. Oh yeah, and then I want to convert it to HSL. There we go. So we'll save this. So now in order to use this modifier that we've created, we need to update the CSS class for one of the widgets. So going to our index.html file, if we go down to our widgets in the sidebar, I'm going to add a class of grid underscore widget dash dash green. And we'll save that. And let's check out the website. Okay, so now we can see that while the other widgets are the magenta color by default, the first widget that we added that grid widget green class to is green, since it's taking the background color property from the green modifier that we just made. And if we look at the other widgets, their background color is coming from the default grid widget background color. You can see it, it's getting overridden in the first widget because of this additional class. And again, the reason it's getting overridden is because of the cascade. So in our styles, the green comes after the default background color. So it takes precedence over it and it'll override that default magenta color. So if we look at the HTML classes that we had to write in our widget here, it might feel kind of repetitive or like extra work or extra typing to have both the grid widget class and then the grid widget green class. And this makes the class names kind of long, right? There are a couple ways in Sass that you can keep the BEM modifier behavior, but without having to write both classes in the HTML. So let me just show you those now. So one way we can do this is by using the Sass extend at rule. So what this does is the extend at rule will allow you to kind of copy rules from grid widget into grid widget green without having to actually duplicate style rules and manually typing them out a second time. So to do this in the green modifier selector, what we can do is type at extend, and this is right in the style rules, dot, since that's the class signifier, grid underscore widget. So what this is doing is now the green modifier is going to take both these styles from the grid widget and use them in itself. So this means if we go back to our HTML file, we can actually get rid of the first grid widget class. And now we just have grid widget green. And if we go into our website, it's still green, which is great. And if we inspect that first widget, grid widget green, you can see the background color of green is there, but also there's a compound selector using grid widget and grid widget green, and it's giving both of them that default background color as well as the padding property. And again, this is because we used the extend Sass at rule. However, you may have noticed that when we were writing the extend rule, we had to fully type out dot grid widget. Like we can't do something like, ampersand underscore widget. And let me show you what happens if you do try to do that. We say there's an error And let's check it out. It says parent selectors aren't allowed here in the extend. Now there is actually a workaround for that, and that is by using a Sass variable that will load the parent class. So what we can do is in the widget selector, I'm going to create a variable right here calling it $widget. And I'm going to set it to ampersand. So what this is doing is creating this variable that will get set to the ampersand, which is the parent selector of this, which ends up being grid__widget. So now, oh, I shouldn't have saved. But so now in the extend rule, what we can do is type in $widget. And we have to, and because we're using a variable inside the Sass rules itself, we actually need to put it in curly brackets and begin it with a hashtag. And this is just how you display Sass variables in your Sass styles itself. Okay, so now it's working. We don't have the error anymore. And if we look in our website, you can see that it's still loading the default grid widget styles in the grid widget green modifier selector. And if you're wondering, this hashtag curly brackets thing, it's called interpolation. So it's basically how you can load the value of a variable in a Sass selector name. And writing this out is basically the same thing as writing out grid__widget. I mean, I don't really use this very often just because I feel like it's the same amount of work and then you have to create this whole new variable. So if I ever had to use this, I would write it this way without creating the variable, but it is a good tool to know just in case you do run into a case where you would need to use that. And one word of advice, if you are using the extend rule, I would only use it for elements that are closely related to each other. For example, like what we have here with the widget and then the green extending the grid widget rules. Like if you start using extend to copy style rules from unrelated elements, like in completely different Sass partials, it can cause some confusion when you're trying to track down a bug in your website later on down the line. So I would use extend very sparingly. And there is yet another way in Sass that we can load the widget default styles in the modifier selectors. And this is by putting the default widget styles, like the padding and stuff, in a Sass placeholder. A placeholder is a special selector that you create in Sass that just contains a set of style rules. And it won't generate any final CSS style rules by itself, but only when you're actually using that placeholder somewhere else in your styles. So let me show you what this looks like. So I'm going to create the placeholder up at the top of the grid.scss file. So to create a placeholder, you start by typing the %. That sort of signifies to Sass that it's a placeholder. Then I'm going to say widget. And in the curly brackets, I'm going to put the padding rules that we added. So here we go. So I'm taking this here and putting it in the widget placeholder. So now when we want to actually use the styles from our widget placeholder, what we can do is in the green modifier selector, instead of extending grid widget, we can say extend and then the name of the placeholder. So %widget. So let's save that. And here's our website. So the green widget looks okay. The problem, however, is that let me just move this over a little bit. The problem is that the default widgets, the not green ones, don't have that padding anymore, right? Because we moved it outside of the default grid widget styles. But you can see that it's getting added to the grid widget green selector. So if this was kind of in the real world, what I might do would be to move the background color into another modifier. So I might create another modifier called ampersand -- magenta, and then move the background color property there. And it also would have to extend the widget placeholder. So when we save, but we'd have to actually, I need to add the class to the HTML. So first widget is grid widget green. So then I'll just add this to the second and third widgets. So grid widget dash dash magenta. And the same thing for the last one, magenta. Okay, so now in the website, it looks kind of like the way it did before, where we have these two modifiers, grid widget green and grid widget magenta. And they both are inheriting that padding property from the placeholder that we created. So using the extend rule, whether it's using with the placeholder or with like some parent class to get those properties, it is helpful because it allows you to basically copy and paste style rules from one place and use them in multiple other places in your styles. However, I do know that some people don't really like using extend very often because if I show you in our final CSS file and save to prettify it again, it creates these compound selectors for any style that uses the placeholder or the class that you're extending. And some people don't like these compound selectors because, you know, the more times you use the placeholder or whatever, the longer this selector is going to be. I personally don't think it's a huge deal, but there are some other options as opposed to using the extend rule that you can use to kind of accomplish the same things. So I'm going to show you one of those things right now. So going back to our grid.scss file, this method of instead of having to use the extend rule to copy styles, you can create something that's called a helper class or a utility class. So in our grid.scss file, to illustrate this, I'm going to delete the placeholder in both cases. And I'm going to move that padding back to where it was originally in the grid widget selector. So now we're back to having the generic styles in grid widget, and then we're adding the background color with the modifier. So let's just make sure this is working. Okay, it looks good. We got our background back. But oh yeah, because we have to, the padding's not here because it's in the grid widget class, which we had removed previously. So we need to add those back. So again, we're going to have two classes here. So grid widget green, grid widget magenta, and then grid widget magenta again. So now in our website, all right, so now the sidebar widgets have the background color and they have the padding. So in some senses, you could consider that this second class is kind of accomplishing what we're going to be doing with the helper classes, but it's really just a matter of the way that you want to name things. So let me show you. Going back into our grid.scss file. So instead of having the ampersand dash dash magenta, what we're going to do is make it its own class. So we're going to replace the two dashes with a dot, which means it's going to be an additional class. And we'll do the same thing for the green. And the reason that we still need the ampersand here, with no space between the ampersand and the dot for the class name, is because we're going to add this magenta class in the same element as grid widget. So let me show you. So now instead of grid widget green, we're not using a modifier, so it's just going to be grid widget and then an additional class of just green. And we'll do the same thing for magenta for both these things. Okay. So now going into our styles, we can see our class names have changed, but our styles look good. In the first widget, we have grid widget and then green. So you can see the selector, there's no space between grid widget and green because the two class names are in the same element. So anytime you want a selector where you're selecting multiple class names in a given element, you need to make sure there's no space between the first class and then the dot of the next class. If you have the space, that means it would think that there's two elements. So the parent would be grid widget, and then after this space, it would be another element with green. But since we have both class names in the same element, you need to make sure there's no space. And this is just how CSS works. This isn't a specific Sass thing, but that's why we need that ampersand in Sass to make sure there's no space. And if we, just for illustration purposes, if I did delete the ampersand, if we look in our final CSS styles, let's go down to the widget area. We'd see here that in the final CSS, the selector would be grid widget space and then magenta class. And this would be looking for a child element of the grid widget div that has a class of magenta. So this is why this is not working. So that's just one thing to keep in mind. I guess we could give this a class of green. So now the H2 element is a child of the grid widget div, and that's why just the H2 is having a background color of green. But obviously that's not really what we want. So let's go back and put that ampersand back so that it'll look for both classes in the same element, which is what we have. So in this example, the green and magenta classes are what we call helper or utility classes. This means that the class name only has, one or a very small number of styles associated with it, and they're usually very descriptive with the class name. So the class name sort of tells you what they do. For example, the green has just a green background color attached to it. Magenta just has a magenta background color attached to it. And so they're called utility classes or helper classes because you can reuse them in different elements. So if I had some other random element somewhere else in the website that I wanted a magenta background color, I could just add this magenta class to whatever element and it would take that style. So that's one really cool thing about having these helper or utility classes. Obviously, if we did want to do that, we would have to take out the magenta and the green classes into a new Sass file. So let me show you what that would look like. For these helper classes, I would probably maybe put them in globals, maybe in the colors.scss file. So let me copy these, save, and then I'll add it to the colors SCSS file. And we don't want the ampersand on our root level of our Sass styles because there's no parent to select, so it would actually throw an error and it wouldn't work anyway. So now we save. Okay, good. There's no errors. Go back to our website and everything's still working. And this is really just because we moved that green and magenta helper classes into a new Sass file. So now we can use the green and magenta colors anywhere. So let's say we wanted to make the main element have a green background too, or maybe magenta. What we could do is go into our HTML and then after grid main, add magenta and save. And then we would have to, in that case, remove the background color properties from here. So I'm just going to comment this out for now. Save that. So now our main has a magenta color. And if we wanted to, we could change that to green as well, just by modifying the magenta class to be green. Now, since utility classes are reusable, they are a nice way to let you modify the styles without having to keep creating new style rules. And this can come in really handy, especially if you're using a CMS, a content management system like WordPress, because you can customize the website code so that you can set CSS classes on elements directly from the CMS. So for example, I could link up the CMS like WordPress to a dropdown in WordPress that has the different background colors set, and whatever you select in the dropdown, it would automatically get added to the website classes. That can be handy because if you're working on a team or with a client, they can make changes to the website through the CMS without having to, come to a developer to make an actual code change and then having to deploy that change up to the production website. And if you have a whole system of utility classes to control things like not just background color, but, flexbox and grid layouts, font sizes, and other styles, it can make making new additional pages in your website easier since you've kind of already done the work and created all those helper and utility classes. And this is exactly what utility-first frameworks like Tailwind do. They're essentially a whole web design system that lets you build pages and elements from existing styles and just add them by adding the class names to your HTML elements. It is a different approach to building websites from BEM and what I usually do, and I know it's not for everyone. One downside is that you might end up having just a ton of classes and class names, which can make your styles bigger. I know Tailwind has kind of a solve for that. And also, if you're building a new website from a completely new design, no matter if you're using BEM, utility first, or other approach, you're going to have to build all the styles out the first time anyway. So in some ways, it may not matter what approach you use, and you can just kind of use your own preferences to guide you. I personally like using a combination of both. So I'll use mainly the BEM with some utility classes mixed in. And I like this because I feel it's kind of organized, but it does give you some of that flexibility that comes with using utility classes. And you'll see more of this as we build out the actual course website later in this course. So that's the intro to Sass and responsive design. I hope it's helped explain some of the basics, and feel free to let me know what you thought down in the comments. And if you're interested in more, check out my full course, Responsive Design for Beginners, linked in the description below. So thanks for watching, and we'll see you in the next one.